So guys, first topic is lexical convention. So similar to C language, also called tokens, they can be comments, number, string, identifier and keywords. Next thing is actually Verilog is case sensitive language. All keywords are in lowercase only, right? So now try to understand that what are the subtopics of lexical conventions, like what are white space, what are comments, like this. So first of all, let's write 3.1.1.1. These are white space. So it is just blank space like tab and new line. Next one is it improves readability and indentation or alignment of a code. White space is ignored by simulator. It cannot be a string. It cannot be ignored in a string, right? So what is white space? As I am giving tab from here to here, this is called white space, right? So it helps to indentation or alignment of a code, right? So let's take some small example to try the concept behind white space using coding part. So let's say module white space and module. So guys, in Verilog, every piece of code only can be written inside module and end module. In regarding module and port list, we will discuss later. Okay. So for now, just try to understand only white space. So let's declare some variables like reg 7 down to 0a. Next one is 7 down to 0v. String name underscore 1. String name underscore 2. Initial, begin, end. Can write like a is equal to tick b 1010 underscore 1111. Similarly for b, we can write like this. After that, name underscore 1 is equal to, let's say, Verilog HDL. After that, name underscore 2 is equal to, can write like this, Verilog HDL, like this. So what we have done right now, we have initialized some value to our variable A, another value to variable B, and some string to name1 and name2, like this. So we have used here, that is called underscore. So it improves the readability. As I mentioned over here, it improves the readability. Okay. So but it cannot be ignored in the string. So what is the mean of that? If I am writing like this, so simulator will ignore this part, means this underscore part, in both value A and B. So for now I have initialized the value to A and B, and after that I will try to print this value, so we can see the result. Okay. Similarly for string, as I mentioned over here, it cannot be ignored in the string. It means this space cannot be ignored, like this, it will be in our result, it will reflect in our result. So let's write some display statement to print these value. Display statement in Verilog is similar to printf in C language. So $display A is equal to let's say percentile B A. Similarly, B is equal to percentile B of B, $display. Here I have to print the string, so name underscore 1 is equal to percentile S. After that, name underscore 1, here name underscore 2 is equal to percentile S, here name underscore 2. So this is called $display. So $display is the system task in Verilog. So it is used to print the output. So first of all, we need to declare from which name we want to print the output. So here name is A is equal to percentile B. That means I want to see the output in binary format. Let's say I want to see the value in decimal format. So I can write percentile D. Let's see. Here I am writing D, and here I am writing printing in decimal format. Okay. Similarly, here name underscore 1 is equal to percentile S. So this is the string. For string type, we have to declare percentile S as for string, right? So let's save this code and try to run it and see what is the result. There is some error, so let's check in line number 20 near EOF syntax errors. So line number 20, okay, we have missed AND module. Let's check inside the code, it is there. So it is just copy paste mistake. So guys, as you can see now, we have initialized the value of A like this 1010 underscore 1111, but it is not printing underscore because this is the white space. So it is just for readability, to improve readability purpose. Okay. Similarly, here I have mentioned 3 underscores, but it is not reflecting in the output because it will be ignored by the Verilog simulator. Now in string I am writing, okay, let's see in decimal format. So here this statement printing in decimal format A is equal to percentile D. So this is the value of A in binary format. When you convert this value to decimal, you will find 175. Okay. So in string I have write Verilog space HDL. So it is printing in the same manner, Verilog space HDL, because as I mentioned over here, it cannot be ignored in the string, right. Here I have give some byte space over here. After that, here I have put underscore, here 1 byte space, here 1 byte space. So it is printing same with white space, because white space cannot be ignored inside the string. Okay. So guys, this is all about the white space. Now let's come to the next topic, that is 3.1.2, that is comments. So they inserted in Verilog code to improve readability and documentation. After that, Verilog supports two types of comment. They are single line comments and multi-line comments. So let's see one more piece of code to understand the concept of comments. So just declare module, let's say module name is comments. And module, inside that initial, begin, end, and just write simple some display task like dollar display. This is first line comments, and this is second line comment. This is third line comment, fourth line comment, fifth line comment, sixth line of comment. So just copy this code and try to run it. So as we can see, it is printing the same. This is first line comment, second line comment, up to this is sixth line of comment. So now let's comment this statement. Let's say I don't want to print this information. This is fourth line comment. So just use double slash and try to run it again. So as you can see, first, second, third, and it ignored fourth line because it is comment, and fifth and sixth. So this is called single line comment. Let's say I want to hide multiple lines. So there are two ways. I have to mention like this. So it will ignore first, second, and fourth comment. As you can see, only third, fifth, and sixth comments line are printed. So this is called single line comments. Second one is called multiple line comments. Means let's say I want to comment from this line, my second line, to, let's say, up to here. So asterisk slash. So now it will only print the first comment and sixth comment. As we can see, only first comment and sixth comment. So it will ignore all these comments line. Okay. So this is something called comments. So our next topic is three point 1.3, that is operators. So used to perform different types of logical and arithmetic operations, right. Next point is there are three types of operators are there. First one called unary operators, second one called binary operators, third one called conditional operators. So let's say one more piece of code to try the understand of operators, but in brief we will discuss later. So for now just try to understand the basic concept. Let's say module name is operators and module, so let's say reg A, reg B, let's say integer I, reg out. So these are our some variables. So this is, guys, this is something called the variable declaration, right. And let's say after that initial begin end, inside that I am writing, so let's say now this is something called comment. Inside comment, for my readability, for my understanding what we have done in the code, I am writing unary operation. Okay, so this is the comment part. Now inside that I can write like out is equal to not of A, right. After that dollar display, inside that I am writing unary operation, that is out is equal to percentile B out. So this is the means, this symbol is for negation, means not of. So let's say whatever the value of A, it will invert that value and print the value of out. So for before that we need to initialize the value of these variables, right. So here again make a comment, variables initialization. So we can initialize the value like A is equal to 1 tick B1. Similarly, B is equal to 1 tick B1, and let's say I is equal to 10. So this is our unary operation. Now next again make a comment, binary operation. In binary operation I am writing like out is equal to A or B. So this symbol is for OR gate operation, right? And here some display statement, dollar display. Inside that I am writing binary operation, that is out is equal to percentile B out. Okay, let's do one more binary operation, A and B. So this is called AND operator, so it will ANDing the value of A and B and feed to the out. Okay, next one is called conditional operators. Conditional operators are like, I am writing out is equal to, some conditions would be there, let's say like this, let's say my I is greater than 5, after that question mark, and I am writing 1 colon 0. So write display statement, here I am printing conditional operation, that is out is equal to percentile B out. Let's say here I am comparing is less than 5. So what is the mean of this statement is, first of all it will check whether the value of I is greater than 5. Okay, so if this statement is true, it will print 1. If this statement is false, it will print 0. Similarly, it will check in this statement, it will check if the value of I is less than 5. So if the value of I is less than 5, it will print this value, else 0. And here we can check the value of I is 10, right? So it will check both conditions. So just copy the code. Try to run it. So guys, our first display statement is for negation, means out is equal to not of A. So we can see the value of A is 1. So the invert of that 1 is 0. So it will print unary operation out is 0 from this statement. Okay. For next time, for binary operation, we have performed OR operation between A and B. So we can see the value of A is 1 and the value of B is also 1. So 1 OR with 1. So it will give high output, means 1. So you can see binary operation out is 1. Okay. Next one is ANDing operation. So what is the AND 1 or 1? It will be high. So it is again printing binary operation out is equal to 1 from this statement. After that, for conditional operator, so we are checking whether the value of I is greater than 5. Yes, 10 is greater than 5. So it will print 1 as a output. So out is equal to 1. Here I am checking whether the value of I is less than 5. So I is 10, but 10 is greater than 5. So this condition is false. So when this condition is false, it will print this value, that is 0, right? So guys, this is the way of operator, how the operators works in Verilog. So now come to the next point. Next point is number format. As we have mentioned 1 tick B 1. So what is the mean of these lines? What is the mean of 1 tick B? Yeah, 1 tick D, like this, right? So this is number format. So number can be presented in decimal, hexadecimal, binary or octal. So these are the format in Verilog, right? So now come to the next point, that is side number. So what are the side numbers? Inside numbers size should be written in decimal. Next point is format of size number is, so what is the format we are describing, like size in decimal, after that tick, base format, after that value, or we can say number. So this is the format how we can declare a side number. Okay, so size is always in decimal. Let's say here I have declared tick v1. So this 1 is the size of the number. Okay, this is in decimal. After that tick base format. So this is the symbol of tick, after that base format. It may be decimal, hexadecimal, binary. So here I am using B. B stand for binary. O stand for octadecimal. Sorry, octal format. Similarly, uh, you know, hexadecimal, we need tick H. Okay, and after that number. So what is the value? That is 1. After that, okay, our next point is unsized number. And in unsized number is base format is not there, but it will be decimal by default. So maybe a base format is not there, but it will take it as a decimal. Next point is number without size specification have default number of bits depending upon the simulator or machine. The next point is, but the default number of bit should be at least 32 bit. Okay, the next one is negative number. So negative number can be written by putting a minus sign before the size of a number. Next one is string. A sequence of characters enclosed in a double quotes like this. Okay. Next point is every character of a string consume 8-bit space in the memory. So what is a string? We can see in this example, these lines are called, but inside comments this is called a string. What the declaration format of a string is like this: a string, after that variable name, that is name underscore 1, and after that I am writing name underscore 1 is equal to inside double quotes. So whatever we have write inside the double quotes, it will print as it is, as the output. This is something called a string. And each character of a string means each alphabet will consume 8-bit memory space, right? Next one is identifiers. So they are the name of variables. Next point is they may have alphanumeric characters and or underscore and dollar sign. The next point is but they cannot be start with dollar sign. Next point is they cannot contains only number. So we will see what are the identifiers in the example. So next thing is keywords, right? So okay, let's see. They are language defined special identifiers, also called construct, right? All are in lowercase only. So let's see one example to understand all these concepts regarding 3.1.4 topic. So let's say module num format, and module, inside that I am writing, let's say integer a, integer b, integer c, integer, let's say minus underscore num, and one string and the name. Okay, after that initial, begin, end. Inside that, first of all, side number. So let's say I am writing A is equal to 4 tick B 1011, and after that dollar display. Inside we can write like printing side numbers or number, that is A is equal to percentile B, here A, right? For next time, let's say I am writing the same number but with underscore, right? After that, unside number. So let's say I am writing my, let's say B variable, B is equal to 1012. So that is without base format, right? Here I am writing dollar display printing outside number B is equal to percentile D. Let's say I want to print this in decimal format. After that B, right? So we can write like percentile B, percentile D, yeah, or percentile H as per our need, right? So for next time, let's say I am writing C is equal to tick H 412. So that is without size. Because I didn't mention any size. Okay, so dollar display printing, actually this is without base actually, and this is without size unside number, right? And that is C. Now let's take minus number. So minus number, that is, let's write minus num is equal to let's say minus take like 5 tick and decimal 25, let's say, and you can write dollar display inside that you can write printing minus number, that is minus num is equal to percentile D minus num, right? After that, let's say next point is string. So we have declared one string with the variable name is name, so you can write name is equal to Verilog HDL After that, dollar display, inside that printing string name is equal to percentile s and name. Our next point was identifier and keywords. Okay. So just write a display statement to understand what are the identifier and what are the keywords. So dollar display, inside you can write like string is a keyword while name is a identifier. Means I am talking about this thing. So as we have mentioned, string name. So string is a keyword. It is a predefined keyword of Verilog, but name is the identifier. Means it will help to identify the string, or we can save the string inside the variable name. Okay. So okay, we have done this coding part. Now just copy this code and we'll try to run it. Okay, so our first statement was printing side number a is equal to percentile b a. So we have declared like 101011. So you can see 1011. So you can see 1011. So it is giving some extra zeros. So you can write like this, percentile 0b. Here also percentile 0b, and just run it again. Now you can see printing side number 4 tick B, that means 4 is in decimal, so total number of digit, so that should be 4. So 1 2 3 4. After that tick B stand for binary format, that we are initializing these value in binary format. Okay, so this is printing the same. After that I also used the same value of A with underscore, so it is printing without underscore because it ignored the byte space. It is just for readability purpose. After that unsigned number, so 1012, that is printing without base size, right? So we have initialized B is 1012, so it is printing B is equal to 1012. After that we are printing without size, so that was in tick H for hexadecimal format, and the value was 412, right? Here 412, and we are printing in decimal format. So in decimal format the equivalent of 412 will be 1042, or you can check with this percentile H. You can print in hexadecimal format. Just run it again. So that is printing without unsigned number. Printing without unsigned number, that is 4012, what we have initialized, right? And next one is minus number. So for minus number we have initialized minus num to minus 5 tick D25. So minus stand for minus number, 5 is number of bit, maybe maximum 5, and tick D is decimal format, that is 25. So it is printing minus num is equal to minus 25. Okay. After that string we have write a string Verilog space HDL. So it will print in same manner, Verilog space HDL, because white space cannot be considered inside the string. Oh, sorry, it will considered inside the string, it cannot be ignored inside a string. After that next is identifier and keywords. So string is the keyword while name is the identifier. So this is the string, it is a keyword, and name is the identifier, right? So we have done about the number format, all these things, and we have take example of side number, unsigned number, negative number, string, and identifier and keywords also, right? So come to the next topic, that is 3.2, that is data types. So Verilog supports four types of data values that are mentioned below. So first one is 0, that is false, or can say logic 0. Next one is 1, that is true, can say logic 1. Next one is x, that is unknown, it can be logic 0 or logic 1. Next one is z, that is floating state, means can say connection is totally isolated or not connected. Okay, so next point is that is 3.2.2, that are net data type, net data types. So they represents the physical connections between hardware elements. Next point is also called wire. Similar to physical wires, and the most important point is default value of net data types is high impedance, that is Z. Next point is 3.2.3. Next data types is registers. So used to store the data values the default values not values, it is value actually. The default value of resistor is X. Next point is 3.2.4 called vectors. They are net or reg data type can be declared with multiple bit width. Called vectors. Next is 3.2.5, that is integer, real and time data type. So let's see one by one. First of all is integer. So it is an general purpose registers can hold up to 32-bit value. It can store signed and unsigned numbers. Okay, the next data type is real. So they can store floating point value. Next one is after real, next one is time. So can store floating, not actually, okay, time. So it is unsigned, 64-bit variable, can hold simulation time at given point. Okay, next one is $time is a system task, gives current time. After that, next point is real time. So they are similar to time, but can store time in floating quantity. Okay, next topic is that will be 3.2.6, that are arrays. Can be reg, integer, time, real or real time data types. Next point is regarding array, can be single or multi-dimensional. Next point is 3.2.7, that is memories. The first point regarding memories is they are storing elements used to store, or we can say read data at given location. Right, and can be modeled using 1D, means one dimensional array of type reg, means we can declare it as 1D reg array. Okay, next point is 3.2.8, that is parameters. What are parameters? It allows a Verilog code more reusable for different specifications, right? So these are some data types, and now let's take some example to try all these concepts, right? So example is let's say module top and module here. I am writing like integer a reg 7 down to 0 b. After that I am writing like reg c after sc let's take one variable like real r. After that take some time, let's say t. After that declare it reg 7 down to 0, that is mam 15 down to 0. So this is reg type array, or can say memory declaration. Next data type is integer I, initial, begin, end. So after that let's write a is equal to 0. Okay, after that write dollar display printing value of integer a is equal to percentile d, that is a. After that let's say a is equal to 1 and printing the value of a. After that sorry, let's say I am writing take next variable, that is b is equal to let's write tick h x, means in hexadecimal format x. So printing value of reg b is equal to percentile d b. Okay, after that let's write, okay, like this. B is equal to tick HZ, means I am giving high impedance value, and dollar display printing value of reg. B is equal to, let's say in decimal format, percentile D, that is B. Also we can write like printing the default value of reg C. So we didn't initialize C with any value, right? So let's test the default value of resistor. As we have mentioned, it should be X, and here I am writing C. After that I am writing like R is equal to, let's say 13.92. After that I am writing dollar display printing real data type, that is R is equal to percentile F. F for floating state, means when we want to see the value in dot format, means decimal format. So that is R. After that we can write like T is equal to dollar time. So as I have mentioned it above, that dollar time is a system task, right? It will take the current time and feed this value to the T, and let's write dollar display inside. I am writing like printing time is equal to percentile T, time is equal to percentile F in floating state, and after that I am writing P, and after let's use one loop, let's say for begin end. Inside for I am writing I is equal to 0, I am writing I is less than equal to 15, and I plus is equal to 1, and here I am writing mem of I is equal to dollar random, and here dollar display printing data is equal to percentile H from memory location that is percentile 0D, and here I am writing mem of I comma I. So this is the for loop. In coming time we will discuss brief about the Verilog loops. There are various kind of loop Verilog supports, like for loop, for each loop, and while loop, repeat loop, like this. Okay, so for now we have declared one memory. That means this is one dimension, means 7 down to 0. So what is the mean of that? And this is 15 down to 0. So what is the mean? So 15 down to 0. So that will be total 16. So what will be 16? 16 will be locations in a memory, or we can say the memory depth is 16, and each depth or each location can hold 8-bit value, right? So this is the 8-bit value, and this is the all over memory locations. So 16 memory locations with each memory, each location can hold only 8-bit value, up to 8-bit value. Okay, so what we have done over here, I have write a loop I is equal to 0 less than equal to 15. So my loop will start from 0 to 15, and here I am writing I plus is equal to 1. So it means I plus plus, or means I am incrementing. We can also write like this, I is equal to I plus 1, I is equal to I plus 1. Okay, so increment by 1. So first of all I value will be 0, after that 1, after that 2, up to 15. So here I am writing mem, inside bracket I am passing I. So it will take first value 0, after that in second time it will take value 1, after that 3, like this, dollar random. So dollar random is a system task, gives random values. So after this statement, so at 0th location, so first location of memory index is 0, so at 0th location 8-bit value will be stored. So 8-bit random value will be stored, whatever value it will give us, and it will stored on the first 0th location. After that I become 1, in second iteration I become 1, so it will take some another random value for first location, after that similarly for second location, third location, right? And here dollar display statement I am writing printing data percentile h from memory location this. So here percentile h is printing data. So memory of I, by using this, if I am writing mem square bracket I, so from this location, let's say in first time my I will be 0, so whatever we have written as 0th location it will print over here from memory location. So from which location it is printing, so percentile d and gives value of I. So similarly for data, some random data will be printed from 0 location, after that some random data will be printed from first location, from second location, like this. Okay, so let's run this code. So we can see printing value of integer 0, a. So as we initialize a is equal to 0, so it is printing the value of 0, that is right. After that we have initialized the value of a to 1, it is printing the value 1, that is right. After that we have initiate the x value to b. Okay, so it is printing b is equal to x by this statement. After that we have initialized high impedance to register B. So it is printing high impedance from register A actually. It is not A, it is actually B. Right. So we was here, it is printing X and Z in from register B value. After that we have printing the default value of reg C. As we can see, we have declared C as res type and we didn't initialize any value to C. So it is printing the default value of C. What is the default value of C? That is X. So it is a very good interview question. Maybe asked that what is the default value of register. So default value of register will be always X. Okay. After that we have given some real value 13.92 and we are printing using percentile F for floating. So it is printing the same 13.92. Okay. After that we have taken t is equal to dollar time and printing the time using floating percentile f t, but it is taking 0 because there is no delay in the code. To see the value, any time value, we can write like this, let's say hash 20. So we are giving actually 20 nanosecond delay to check whether dollar time is working or not. So as you can see, now printing time is equal to 20.000 from this line. Okay, after that this memory concept is there, so we can check printing data 24 from memory location 0, 81 from memory location 1, and similarly 0 to 15. Okay, so these data 24, 81, 09, 63, 0D, 8D, 65D, it is generated by this system task, that is called $random. Okay, so okay, our next concept is parameter. So what is the parameter, how they work? So let's see. Let's write one more piece of code to understand the concept behind parameters. Let's say module top and module, and how we declared the parameter. Parameter, let's say data size is equal to 4. After that parameter, let's say address size is equal to 16, right? After that just declare one memory, so we have to declare like this, that is data size -1 down to 0. After that the memory name, let's say memory name is F, and here we have to pass the address. So address size -1 down to 0. After that take some integer, that is I, initial, begin, end. Inside that we can write for begin, end. Inside that I is equal to 0 and I is less than or equal to address size -1 and I plus is equal to 1. After that inside for loop we can write mem of I is equal to $random and $display we can write same as above, printing data is equal to %h from location %d. Here we can write mem of I. So now try to understand. This is the same piece of code whatever we have write in these lines, but here we are using parameter. So how we can declare the parameter? Parameter is declared using the keyword, predefined keyword, that is parameter. After that parameter name. So here parameter name is size, sorry, data underscore size, and we have initialized the data size is 4. Similarly another parameter we have taken address underscore size and initialized with 16. So here you can see the difference in this line. Just comment this line. So this was your data size, 8-bit data size. So let's say here I have declared data size is 4, right? So I have here mentioned data size -1. So what is the value of the data size? That is 4. So 4 minus 1, that is 3 down to 0, right? After that here I am writing address size -1 down to 0. So what is the address size? That is 16. So 16 minus 1, so that is 15 down to 0. So it will be like this, 3 down to 0 and 15 down to 0, right? So this is the same thing. So let's copy this code, and here we can see I start from 0 and increase every time increased by one value only, and here I am writing I is less than or equal to address size -1. So again what is the address size? 16. So address size -1, that is 15. So it will start from 0 and run up to 15 like this. Okay. So let's check. So we can see it is working fine. Data is 4 from 0th location. Similarly, data is 6 at 15 location. So what is the advantage of parameter? Now let's say it is working for 4 and 16. Let's say I want to do it 16. I want to run the same code for 16, means it should, my memory should capable to store 16 bit at each location. So we have to just make only one modification over here, and this code will work for 16. Now you can see this is increased. Now let's say I want to change my address size or my memory depth 16 to 32. So we can only change here 32, and whole code will work for now 16 bit. 16 bit can hold at each location, and total number of location now we have modified to 32. So now run it. So as we can see, it is going from, it is starting from 0 to 31, the same code. So only we can, so this is the advantage of parameters. Okay. So as per our need, we can make minor modifications over here, and whole code will run accordingly, right? So okay. So next point is 3.3, that are system task and compiler directive. So 3.3.1. So first of all, we will discuss system task. Perform certain routine operations. Next point is all system tasks start from $sign. So let's see some example like $display. Okay, so this is position based printing mechanism. Next one is $monitor. So this is print when the value change. Next one is $strobe. Print, we can say last or final value only. Next one is $write. Print message, but don't have a new line character. Okay, after that $stop. suspend the simulation and put it at interactive mode. Next is, let's say, $finish. So $finish is used to terminate the simulation instantly. So let's take some example. Let's say module top and module. So what is the difference between our $stop and $finish? $finish will terminate the simulation. Okay, so we can mention some time. After that we have to write $finish. So up to that time it will run the simulation and terminate the engine immediately. And $stop is used to suspend the simulation and put it the interactive mode. Means at backend simulation will run, and meanwhile the engineer can debug the code. $display is positional based printing mechanism, as we have used earlier in the code, like here. So whenever at which point we are writing $display, it will print the message accordingly. But $monitor only prints the value when the output is changed. Let's say for 10 cycle the output is no change, output don't have any change, so it will not print any value. At the moment it file change in the output, then only it will print the message, right? After that $stop, so it will print only final value, the last value. Okay, after that $write. So $write is similar to the display statement, but it will not take any new line, so it will print all the message in a same line. Okay, so this is the very good interview question, that what is the difference between $display, $monitor, $stop and $write, and how you can justify your answer. So let's take some more example. So let's declare reg 15 down to 0 A, reg 15 down to 0 B, 15 down to 0 C. Initial, begin, end. Inside that can write A is equal to 10, B is equal to 10, or we can write 20. Okay, after that $display, inside I am writing like display C is equal to percentile D, and here I am writing A plus B. Means it will add A plus B, that is 30, and print 30 as the C, means C will becomes 30. Okay, so we can also write like this A plus B, or we can here also write C is equal to A plus B, and then we can write C is equal to percentile D, or here we can write C. So both method are correct. Okay, after that $write. Let's say here I am writing write write C is equal to percentile D, and here I am writing A plus B, right? After that I am writing $stop, $stop, and here I am writing $monitor, right? Now let's say I am changing the value, so I am modifying the value to, let's say, 20, and now I am modifying B to 5. So after that again I am modifying, I am putting the same value 20 and 5, what was our previous value. we didn't make here. I am here I have make a change. A was 10 and B was 20. Now A is initialized to 20 and B is equal to 5, right? And here I am continuing with the same value, right? So let us try to run this code and see the difference between all these things. So as we can see display. So I am writing display for the display statement. C is equal to A plus B. So it will be 30. That is correct. If you write after that write, that is should be A plus B means 30. So 30. And after that, as you can see, write is equal to 30. After that it is showing display is equal to 25, right? So where it is taking 25, it is taking from here, right? So it is not it is printing in the same line. It is not, it don't have any new line character, right? After that write C is equal to 25, display is equal to 25, right? From here this is the right operation, so it is coming from here. So why this is coming after from here to here? So there is something called Verilog regions. Later we will discuss about that. But now, for now, try to understand that why it don't have any new line character. So this is printing in the same line. Similarly, we can say strobe C is equal to 25. So here strobe C is equal to 25, right? What we have mentioned regarding the strobe, $strobe print only last or final value. So here strobe should be 30, but it is not printing because 25 is the last value, because here the strobe is 25 and also here we can see the strobe is 25. So it is only printing the final value. C is equal to 25, C is equal to 25, right? And you can see monitor only printing once, that is 25, because it here the value was A plus B value was 30, but at this instant it become 25. So only it is printing from this point. It will not print from this point because there is no change. Here is 25 and here is 25, while monitor will work only when the output is changed. So here it becomes 25 and previously it was 30, right? So that's why monitor is printing only 25, right? The next one is that is 3.3.2. Next subtopic is compiler directive. So okay, just see few points. All compiler directive start from backtick sign. So what is backtick? This is called backtick sign, right? So some examples are like tick define, or next one is like tick include. So let's take some example, some coding part to try the concept of compiler directive. So module top and module, and the outside from the module we should use like define. We will take the same example what we have done using parameter, the same example. Now we will done the same functionality using compiler directive. So tick define data size, that is 4, tick define address size, that is, let's say 16. Now come inside the module. So always be remember, tick define should be part of outside of the module. Declare the memory reg tick data size -1 down to 0. Let's say memory name is same mem, and after that we can write tick address size -1 down to 0, right? Semicolon, take integer I, because we are going to use for loop. So initial, begin, end, inside for begin, and here I is equal to 0. So the initial value of I is 0. I is less than or equal to tick address size, right? And after that I am writing I plus is equal to 1. That means I should increment by 1 in every iteration. Here I am writing mem of I is equal to $random. After that $display printing data is equal to percentile h from mem location let's say percentile 0d mem of I, after that I. So it is similar to the parameters, but this is called compiler directive. So the format of compiler directive is tick define, after that the variable name whatever you want to put. So I am using two variable name, one is data size and one is address size. So I have initialized data size with 4 and address size with 16. Similarly, as similar we have write in parameters. So reg tick data size -1. So my data size is 4. Now here 4 minus 1, that is 3 down to 0. Mem tick address size, that is 16. So 16 minus 1, that is 15 down to 0, right? So just copy this code. Try to run it. So as we can see, it is working fine. So data, it is taking random data, that is 419 like this, and here it is printing from 0 to 16, right? Also let's say if I want to make any change, so I can also write like 16, and let's say I want to make the depth of memory up to 32, so I can write like this. So now the same code will work for this modified value. No need to write the code again and again, right? So you can see it is giving up to 32, from 0 to 32. So there is some problem. It should not be up to 32. It should be up to 31. So here should be address size -1. That's why it is giving X value over here, because this that location is not there. So it should be address size -1 done. Okay. So what is the address size? That is 32. So it should run from 0 to 31 location. As we can see, now there is not any X value. Okay. So our known values are there, and it is going up to 31 from 0th location, right? So guys, now let's come to our new topic, that is 4.1. What is module? So let's see a few points regarding module. A basic building block in Verilog HDL may have submodules, parameters, port list, variables, continuous or procedural assignments, and some methods like task or function, right? Next point is any Verilog code will be written between module and add module. Next point is it is illegal to write any code outside from module, right? Now let's see the syntax of the module. It will be like module, after that module name, after that port list. Contents of module and add module. Here port list is optional. Maybe some module may have or may not have the port list, that's why it is optional. So let's see one small example like module OR gate. Means now we are going to implement a functionality of OR gate. So let's see how we can write. And module, inside that, so OR gate is the module name, you can take any name, right? Inside that port list. So what is the port list? Port list actually our inputs and outputs. So let's say I have a 2 input OR gate, so there will be 2 input and 1 output. So let's say one input is A, another one input is B, and output is Y. After that we have to tell that inside this port list that which pins are input and which are output. So input A, input B, and output is Y. Right. After that assign Y is equal to A or B. Actually this symbol is responsible for OR operation. So this is the way how we can write a module. After that our next topic is ports. So ports provide module connections to communicates its own environment. Okay. Next point is port may be input, output or in-out type. Next point is internal variable of a module is not visible from environment. So let's see the port connection rules. So port connection rules. So as we have discussed now, the module and the port. So let's see. First of all, let's see what is input type. So internally, input port must always be net type. Externally, the input can be connected to a variable which is reg or net type. Next one is output. Internally, output port can be reg or net type. Externally, connected to net type only. Next is in-out port. So internally, in-out port must be net type and externally in-out port must connect it to a net type. Okay, so these are few kinds of rules. Okay, so these rules are applicable for input, output and in-out type ports. So let's take one more example. Okay, so let's take one example of full adder. So module, let's say module name is full underscore add, after that and module, inside this we have to declare the pins. So A, B, C, these are the inputs and after that sum and carry. So input, after that we can write buyer and A input buyer, B input buyer, C. We can also write like this: input buyer A, B, C. Okay, so both methods are correct. Using this you can implement all, you can mention all the inputs in a same line. output sum and carry, or we can write like sum and we can declare write this like this, wire sum output wire carry. Also we have to mention one thing, by default all input are wire type. Okay, so after that let's write assign carry sum is equal to A plus B plus C. That's it. So what we have done inside that code, we have declared all the pins in the port list. After that we need to tell to the simulator or our tool that out of these pins which one are input and which one are output, right? After that I am using assign. Assign is a continuous assignments, right? As I have right over here, it may have a parameter port list and continuous assignment. So assign is the continuous assignment. Inside that I am concatenating carry and sum. So A plus B plus C. So carry will be go there in carry and sum will be stored in sum. Okay. After that we will see, we will discuss this assignment in later. Okay. So let's write a test bench to check the functionality of this code, whether it is working fine or there is some error, right? So let's write a test bench. So module, let's say top. So as we can see, I have mentioned over here a basic building block in a Verilog HDL may have submodules, parameter, port list and port list is optional. So while we are going to write a RTL, so there will be a port list, but for test bench there is no need for port list. So that's why we have written port list is optional. Okay. The rule is, first of all declare all the input of your RTL as reg type in the test module. Okay. So just declare like reg A, B, C. After that output should be wire type. So wire, let's write in caps sum carry. There is no need to follow the same pins, means you can take any another name as I have mentioned in capital, right? So now we need to connect the port, means we need to make connection between this module and this module. So how we can connect? Let's see, I am writing, first of all we need to declare our module name from which we want to connect the pins. So our module name is full add. After that make any instance name, means any name, any unique name. So let's say I am writing duty. After that let's say I am writing, okay, just write in caps so that the understanding will be more clear. So as we discussed earlier, the Verilog is case sensitive language. That means this A and this A, it is in caps, it is small. So they are the different. Okay. So we have declared the RTL module name, that is full add over here. After that an instance or handle name that should be unique, so that is duty. After that I am writing like this, let's say A, B and C, and let's say I am writing carry. So we have missed one thing over here, right? So if I am passing this A, B, C in the module of RTL, means in this module. So A will connect to this A, B will connect to this B, and C will connect to this C, carry will connect to this carry, or let's say I have forget to write sum. So this is something called unconnected port, because we forget to connect one pin, that is sum. Okay, so that is unconnected port. So just comment this line. Sum. Now the connection is complete between this test bench and this module. So this is the way how we can make the connections, right? After that, initial, begin, end. Inside that, let's say repeat, begin, end, and I am writing 10. After that, I am writing, let's say A is equal to $random. After that, I am writing B is equal to $random and C is equal to $random. So okay, after that, give some delay, let 1 nanosecond only, it is sufficient delay to print the value. Dollar display. So A is equal to percentile B, B is equal to percentile B, C is equal to percentile C. After that, B. After that, sum is equal to percentile B, carry is equal to percentile B. After that, A, B, C, sum and carry, right? So now try to understand this code. So up to this point we have made connection between this module and this module. Okay, after that I am writing repeat 10. So repeat 10 is a Verilog loop, and the functionality of repeat is it will repeat all the statement between this repeat, begin, end up to 10 times, right? Or every time A is equal to $random. So A is a single bit register, so it will generate 1 or 0 randomly for A, similarly 1 or 0 randomly for B, or 1 or 0 randomly for C. After that, we are giving some small delay, because this module will take some small time to give the output. So that's why we are intentionally putting some delay and display statement. For ABC, so it will print the randomized value via $random system task, and after that sum and carry. Sum and carry will comes from here, sum and carry, right? Because we have mentioned sum and carry as the output, these pins, and these pins will connect it to this pin over here with this module with this pins. Okay, so let's copy paste. Now you can see the value of A is 0, B is 1 and C is 1. So sum is 0 and carry is 1. Similarly, for A is equal to 1, B is equal to 1 and C is equal to 1. So sum is 1 and carry is also 1. So in this way we can check whether our code is working fine or not. And you can see every time A, B, C, the value are randomized, right? So let's say you want to make some more random values to check the functionality. So you can make modification over here. You can repeat up to 20 times or 30 times. So as per our need, we can change this value inside repeat. Now you can see, now it will printing 20 times. Okay. again come to here. So the next thing is port mapping. So there are two types of mapping is there: positional mapping, next one is named mapping, right? So the mapping means the port connections, right? So let's write the same code. So in same code, okay, just come to the test bench part. The mapping is the part of this test module or top module. So let's say this is called positional mapping. Means you have to declare A, B, C, sum and carry in the same way as you have declared over here, right? Let's say if I declared like this, carry and sum. So what happens? The carry, the sum from RTL module connected to the carry in the test module, and carry from RTL module will connect to the sum module in test. So the value of carry and sum will be interchanged. That is totally wrong. So this is the wrong way, wrong mapping, right? So just comment this thing. So in positional mapping, you should be take this thing very seriously and carefully, that input A should be connected to A, B should be connected to B, C is connected to C, sum and carry in the same order as you have mentioned over here. Okay, the order will be same. So this is positional mapping. Next concept is named mapping. So how we can do named mapping? Let's see. So first of all, just write the module name of your RTL, that is full add. After that, one instance name, that is DUT. After that, write the brackets. Now inside this bracket we have to perform named mapping. So how we can write? So dot A with A, similarly dot B connected with B, dot C connected with C, dot sum connected with sum, dot carry connected with carry. That's it. So in this way, first of all, dot A, dot means connection, you are connecting the pins. Dot means you are connecting the pins. After that, dot A. So what is the mean of A? A will be from your this module, means your RTL module. This A I am connecting with capital A. Capital is A from the local module, means this A. Similarly, dot means connecting the pins B from this module, RTL module, to this B. Similarly C, similarly for carry, similarly for sum, right? Now run this code again and see whether the positional mapping, named mapping is working or not. So guys, as we can see, it is working perfectly. A is 0, B is 1 and C is 1. So sum is 0, carry is 1. Similarly, both pins A, B, C, all three inputs are high. So sum is high and carry is high. So this way we can connect the port. So in a most complex circuit, we will give preference to the named mapping instead of positional mapping, because sometimes we can forget the order, or by mistake we can connect the pin in wrong way. So this is the way how we can map the ports. So guys, let's come to the next topic. It is topic number 5. That is gate level modeling. So first thing about gate level modeling is low level modeling, actually low level abstraction basically. Second point is user should aware with the circuit using gate level. Now come to next subtopic, that is 5.1, that is gate type. So inside that, logic circuit can be designed using logic gates. The second point is Verilog supports basic logic gates as predefined primitives. Next point is these primitives can be called inside a module. Next point is there are two classes of logic gates as mentioned below. So guys, let's see what are the subclasses of logic gates. So first class is AND gate OR gate. Let's see some points regarding these gates. They have single output and multiple input. Examples are AND, OR, XOR, NAND, NOR, and exclusive NOR, that is XNOR. So now let's see one example. So module, let's say get underscore test, and module, right? So first of all we need to declare the port list over here. So let's say input type are in1, in2, in3 and out. Let's declare which one are inputs and which one are outputs. So input wire, that means it is wire type. By default, all if you are not declaring the types of the variable, so by default it will take it as a wire type, right? In1, after that in2, in3 and output wire type is 7 down to 0, that is out. What is the mean of 7 down to 0? That means it has 7 bits, 8 bit from 0 to 7, right? Now first of all let's see for 2 input gates. So first of all let's see AND gate. So first of all we need to declare the primitive. Primitive means predefined gate functionality. So that is AND. Make some instance. Let's say the instance name is A1. After that, first of all you need to declare the output of this gate and after that the input. So let's say output is coming from out 0. After that in underscore 1 and in underscore 2. So inside gate, first of all you should declare output followed by inputs. Okay, if you declare first input after that output, then definitely it will be error. Now next gate is OR gate and the instance is, let's say, A2. Inside that, let's say this is the output is coming from out1 port and the same input underscore 1 and input underscore 2. So let's say next gate is XOR gate. So make some another instance name, that is, let's say A3, right? So it will be out2, out3, out4, out5, out6 and out7. Now after XOR gate, let's say NAND gate. After NAND gate, next gate is NOR gate. After NOR gate, next one is which one is remaining? XNOR. So XNOR, right? Just alignment of the code, and also we need to change these names. Let's say this is A4, let's say this is A5, and let's say this is A6, right? After that, for 3 input gates, right? So let's take AND gate, and the instance name is, let's say, A7. Next take for example NAND gate, and the instance name is A8. Okay, also as these are 3 inputs, so just increase one more input, in underscore 3, in underscore 3, right? So this is the way how we can write a Verilog code to test the gates. After that, let's create a test bench to verify the behavior of this code. Okay. So let's say module top and module, inside that declare all inputs type of RTL as reg. So reg A, after that reg B, reg C, and next one is wire 7 down to 0, that is out. So you can take any another name, because I am not taking the same name as I mentioned inside the RTL. You are free, you can take any names, right? So always be remember the output should be with respect to test bench or top, the output should be wire type and all inputs should be reg type. Okay. Now let's take one more internal variable, that is integer type, integer I. After that the module connection, right? So let's say first of all we need to declare the same module name inside the test bench. So module name is get underscore test, and inside that just pass all the inputs like A, B, C, and out. So what is the mean of that? Now your A will be connected to in A, this B will be connected to in 2, and this C will connected to input underscore 3, and out will be connected to out, right? After that just use initial, begin, and inside that we can use some loop. Let's say for begin end, and inside for we can write like I is equal to 0. This is the initial value of I, means from this point loop will execute, and I is less than 7, and after that we can write I plus is equal to 1. That means I is equal to I plus 1, right? So now you can write A is equal to $random, similarly B is equal to $random and C is equal to $random. That means $random is the inbuilt method to randomize the value. Okay, there is no need to generate or put some manual values like 0, like 1, 0, 0, 1 kind of things. So it will generate some random values. After that give some small delay #1 and $display, can write like out, inside out can write %0D is equal to %0B, and here you can write I, and here you can write out of I. So what is the mean of that? Here, okay, here I am writing out %0D, means it will print that from which value of I it is printing. Let's say it is printing for out 0, out 1, out 2, out 3, right? That's why my first argument over here is I. So it will update this value. After that is equal to percentile D. At which location of out, the output result is percentile B. So this will print the value from out inside I, right? So okay, and now let's save the code. Just try to run it. There is some error. Okay, what is saying? Get test. Okay, we forget to give some instance name. So let's say my instance name is DOT. Also need to change over here. So it is giving the output. What to verify? We also need to print the value of A, B and C. So let's say A is equal to percentile 0B, B is equal to percentile 0B, C is equal to percentile 0B. A, B and C. So now we can check my AND gate. So first display comes from this statement here, out 0. So output is coming 0, and inputs, because it has only 3 inputs, so just ignore that C part. Okay, so one input is 0, another input is 1, so AND will be 0. Similarly for OR gate, uh, that is out 1, so out 1 is for OR gate, so output is coming high because both inputs are high, right? So similarly you can check for rest of all, and let's say I have to check for the AND gate, 3 input AND gate. So now we can also consider all 3 combinations, the value of A, B and C. Any of value is 0, then output is 0, right? Similarly for NAND gate, you can see the operation, the A, B, C and the output is 0, right? Okay, this is only coming up to out 6, 0 to 6, but it should be 0 to 7, so we can write like this. Yeah, now it is giving right value. So for AND gate, the out 6 is the output. So this is for your 3 input AND gate. Because these 2 inputs are high, but one is 0, that's why output is 0. And in this case, NAND means 1 into 0, that is 0, 0 into 0, that is 0, and the NOT, so it will be high, right? So in this way you can check the functionality of all these gates, right? So okay, let's modify this thing, and also we need to print A is equal to percentile 0B, B is equal to percentile 0B, and C is equal to percentile 0B. Can write A, B and C, right? So this is one thing. Now Next thing is this was our first subclass. Now come to the second subclass. So it will be 5.1.2. Next type is buff or not gate, right? So few points regarding this topic have single input and multiple output. While in previous case, in this case, the thing was reserved. They have single output with multiple input, but here outputs are multiple and input is single, right? Next point is logic behind multiple output is high fan out, right? Next point is buffers also provide isolation from output to input, right? So what is the mean of that? So we will see. Okay, now let's see. Now let's say you have one block or one circuit. This is circuit 1, right? And there are another chip or another circuit. Okay, so let's say this circuit giving some output with 0.25 ampere, right? And these all each chip required 0.25 ampere. So this circuit is not able to deliver the current because let's say I am connecting this thing over here and like this, right? So I am just feeding the output of one circuit to the input to another 4 chips. So this current will be divided. So it will become 0.25 divided by 4 for each chip, right? So the output may be X, right? Because it is not getting the sufficient level. So to avoid such kind of problem, there is a concept of buffer. So let's say just in the same block diagram, 1, 2, 3 and 4. Now we will use a buffer over here. Okay, here will be plus 5 volt and here will be ground connection. Buffer is just a gate or just a chip, right? So what buffer will do, it will take the input from here 0.25 ampere and it will give 1 ampere as a output, 1 ampere, right? And now 1 ampere will be divided into 4. for all these chips. So when you divide 1 divided by 4, so automatically every chip will get the sufficient current from here to here, 0.25, right? So this is the concept behind the buffer, right? So buffer will provide same input whatever you are giving. Means let's say you are giving 1, so buffer will gives strong 1. Why strong 1? Due to this behavior, okay? Because what it will do, it will take the one signal from here, and if it is 1, then it will connect the plus 5 voltage to the output. And let's say if it is 0, then it will disconnect this thing and connect ground to the output, right? So buffer is able to give the strong 1 and strong 0, right? So this is the actual concept behind buffer. This is a very good interview level question, right? Because if we are giving 1 to a buffer and output is also 1, so what is the reason behind that, right? Okay, so now return to our main topic. So guys, let's take some example. uh, Module buffer and module, let's say in underscore 1, in underscore 2, and out underscore 1, out underscore 2, and one more out underscore 3, right? So just declare input is in underscore 1, input is in underscore 2, and output is out underscore 1, out underscore 2, out underscore 3, right? So how we can use the buffer primitive? Like using keyword buff, make some instance, let's say b1 bracket, first of all output. So let's say output is, my output is out1 in this case, and input is in1, let's say, right? Now take another buff and instance is, let's say, b2, and now my output is out, let's say 3, and out 2, because as I mentioned here, they can give multiple outputs. So here I am checking for single output, and here I am checking multiple output, okay, and give the signal input 2, right? Okay, this is done now. So this is the small RTL code to understand the behavior of a buffer. Now come to our module top or test module. So module top and module reg in underscore 1, in underscore 2, and wire out underscore 1, out underscore 2, out underscore 3, right? After that, module instantiation, that is buffer, the instance name is, let's say, dut, and just pass input and output in the same order. So let's say in underscore 1, in underscore 2, out underscore 1, out underscore 2, and out underscore 3, right? Initial, begin, end, just write like in underscore 1 is equal to, let's say, 1 tick b0, right? And after that give some delay, 1 nanosecond, and dollar display can write like in underscore 1 is equal to percentile 0b and out underscore 1 is equal to percentile 0b here in underscore 1 and out underscore 1, right? So this is our first scenario. Now let's come to the next one. So just copy these lines. So now let us change this value to 1 and we will check the behavior after that. In next scenario I am using we have used input 1, so let's take input 2 with 0, right? So input 2 and here is input 2. Okay, and also we will check multiple outputs. So just mentioned over here output 2 out underscore 3 is equal to percentile 0b and here should be output 2 and output 3, right? Now check the same functionality with multiple 2 outputs for high. Okay, so we have done with the test module. So just copy this code. Try to run it. So here we can see it is working fine for multiple output. Means input is 0 and it is giving out 2 and out 3 both are 0 because it is giving strong 0 as output. Here input 2 is 1, it is giving out 1 and out 3 is 1 high, means strong high, but it is giving out 1 and in both case when input 1 is 0 and high, output 1 is x. Why? What is the reason? Means it is not working for this gate buff 1 b1 b2. Okay, output 1. Yes, here there is a typing mistake. I have written int underscore 1 but it was in underscore 1. So let's correct this thing. Now run it again. Now for single input and single output we can see input is 0 and output is 0. Here input is 1 and output is also 1. Okay, so it is working fine with the single output and multiple outputs, right? Now let's see another example of not buff not. So okay, let's write some another code. Let's say module buff not and module. Inside that just mention the same, let's say input 1 input underscore 2 and out underscore 1 out underscore 2 and out underscore 3, right? Just declare input in 1 in 2 in 3, output is not in 3 actually, and output is out 1 and out 2 and out 3, right? After that, just declare the primitive, that is not, it is similar to your NOT gate actually, and write some output first, that is out first, after that the input. So input 1, let's give another name, that is B2. So output, take some other, let's say out 2 and out 3, and let's take input 2. So we have done with the RTL code. After that, module top and module, inside that reg, we can directly copy paste actually. So input 1, input 2, wire type are all 3 outputs, right? And after that, the name is buff underscore not. After that, initial begin end. Inside that, we can mention like in underscore 1 is equal to 1 tick B0, some delay, dollar display. Inside we can write in underscore 1 is equal to percentile 0B, out underscore 1 is equal to percentile 0B, in underscore 1 and out underscore 1, right? Similarly, we have to write rest of combinations, so just now put it to high and see the result, right? After that, take it input 2 and put it 0, and after the delay, because it is also support the multiple outputs, so out 1, out 3 is equal to percentile 0B, so out 2, out 3, right? Now check the multiple note output for high value. So we have done with the code. Just copy this code and try to run it. So you can see when input 1 is 0, then output 1 is high, because it is just doing the NOT operation. Similarly, when input is high, the output is 0, and for multiple outputs, when input is high, okay, so out 2 and out 3 both are high, it should be not. So there may be some issue, they all should be 0 actually. So it is coming from third statement, so first, second, third. So input 1 input 2, we have to change this actually. Now run it again, because we are updating the value of input 2, so it should be input 2. Similarly here input 2. Now we can see for single output, input is 0, output is 1, and if input is high, output is low. For multiple output, input is 0 and both output are high because it is giving strong high, and here input is high and both output are low because it is giving strong low, right? So we have done with node buff. The next concept is buff if and not if. So let's understand the few lines about them. They have additional control signal to control the output, right? After that, these gates are used when a signal is to be driven only when the control signal is asserted. The next point is these gates are applicable when multiple driver drives the signal. Next point is these drivers are designed to drive the signal on mutually exclusive control signal, right? Now let's see the type of these gates are like buff if 1, right? So now few lines about buff if 1. Gives output same as input when control signal is high. Gives output Z, that means high impedance when control signal is low. So as the name buff if 1 means it is only giving the output as same, the input is faded when the control signal is high. If control signal is not high, so output will be high impedance. There is nothing to do with that the input at that time, right? Now the next type is buff if 0. So the gives output same as input when control signal is low. Next point is gives output Z means high impedance when control signal is high, right? Means just opposite to the buff if one. Next point is not if one. Gives inverted output with respect to input when control signal is high. Next point is gives output Z when control signal is low. The next point topic is not if 0. So gives inverted output with respect to input when control signal is low. Next point is gives high impedance or Z when control signal is high, right? So these were some points related to buff if 1 and buff if 0, not if 1 and not if 0. So let's see some coding part to understand this behavior, whatever we have written in few lines. So let's say module buff if and module in 1 into CNTL out 1 out 2. Take input, let's say in underscore 1 in underscore 2 and next input is CNTL. Now output is out underscore 1 out underscore 2. So buff if 1, this is the primitive name, and take some instance name, let's say B1. Inside that first pass the output. So our output is out 1 and input is in 1 and another one is CNTL. Next primitive is buff if 0 and output is out 2 and input is, let's say, into, right? Now we have done with the RTL code. Just come to the test module. So reg in 1, in 2, and CNTL, and where will be out 1 and out 2. Now the module connections. So module name was buffif, take some instance name, let's say DUT. Inside that just pass the connection name, input 1, input 2, CNTL. After that out 1, out 2. Here initial, begin, end, in underscore 1 is equal to 0, CNTL is equal to 1. Give some delay, #1 nanosecond, and dollar display. Inside in 1 is equal to percentile 0b, and CNTL is equal to percentile 0b, and out 1, in 1, CNTL, and after that out 1, right? So we have checked when our input is 0 and control signal is high, right? And next scenario, now let's change the input, right? Now input and control signal both are high. In next scenario, 1 2 3 4, now change the value of control signal. Now it is 0 0, here control input is 1 and control signal is 0. So we have covered all the combinations 0 0 and 0 1 1 0 0 0 and 1 1, right? Now come to the second part. Till now we have checked for buffif 1, now we have to check with buffif 0. So now let's take input is input 2, control signal is same, and here we need to change this thing, input 2, and also we have to change the output, that is output 2. We have done with the code. Some error is there. Test bench line number 7. Okay, we should use some other name because we already use B1. The instance name should be different always. Now for first statement, input is 0 and control is high, right? So because it is buff one type, right? So output is 0. Input is high and control is high, output is same as the input, that is 1. Now we have put control 0 and output is Z because control signal is not asserted. So it is not depending upon the input. Whatever it may be 0 or 1, output will be high impedance, right? After that, for next case, for this case, buff is 0, right? So we have used the signal name into and out to. So control signal is 1. So output is high impedance. Similarly, control signal is 1 while input is high, output is high impedance, because here it will work only when buff if 0 will work only when control signal is 0, as you can see in these two cases. When control signal is 0, so it is giving the output as same as the input, right? Now let's come to the next point, that is for module not if. Declare the same in 1 into CNTL out 1 and out 2. Inputs are in underscore 1, in underscore 2, CNTL. Output are out 1 and out 2. Here can write not if 1 and take some instance name. After that can write out 1 in 1 CNTL. Next is not if 0, instance name is B2 and take out 2 and into. We have done with the RTL code. Now just we will use the previous test bench. So now we have to change the module name. So it is not if and the duty name is correct, and rest of signal and combination of all the signal will be same. It will work, right? It is undefined test bench line number 2. that should be out underscore 2. Notif is not defined. Line number 14. So line number 14, notif. Okay, it is actually notif. By mistake we have write wrong module name. Now we can see input is 0, control signal is high, and we are talking about not if 1, right? So it should required control signal should be high, then only it will give output, else it will give high impedance. So when control signal is high in these two cases, just consider only these two cases for right now. Control signal is high, and because it is buffer but not type, so it will give inverted output. So input was 0, output is high, and input was 1, output is 0, right? When we assert control signal to 0, then the output is high impedance, right? Now come to the not if 0. So what is the mean not if 0? Means when control signal is 0, this 1 or 0 indicate related to your control signal. Just relate control signal with 1 and 0. So when control signal is 0, then only it will give inverted output with respect to the input, right? So just check for rest of combination for out2 and in2. So for in2 control signal is high, but it is 0 type, so output should be high impedance. There we have nothing to do with that the input, right? When control signal is 0, now the output is inverted of the input. Here input was 0, output is 1. Here input was 1, output is 0, right? So this is how we can check or write the functionality of not if 1 or not if 0 type buffer, right? So guys, now let's come to the next topic, that is 5.1.3. It is gate level multiplexer, right? So let's see. We will design 4 to 1 mux bit to select signals. Next point is mux serves a useful purpose in a logic design. They can be connect multiple source to a single line using connect signals. As we know, multiplexer is many into one, right? Next point is, let's see the diagram. Now let's come to the module. Let's say my module name is mux4_1. and module. So now you can see in the diagram it has 4 inputs and 2 inputs as a select line and 1 output. So we need to declare all these signals inside the module port list, right? So let's say out is the output, and in we will take a vector of input, right? So in and S1 S0. Now write input wire, means inputs are wire type. If you are not declare the wire keyword, so automatically in Verilog all inputs are wire type. It will take automatically, right? So 3 down to 0 in and input wire, that is S1 and S0, and output is only one, that is out, right? Now we also need some internal signal. So that was the only module level or top level diagram or block level diagram, right? But we are as we are writing the gate level code, so we need to go the gate level diagram. So you can see we have only declared these inputs I0, I1, I2, I3 as in, and S1, S0 and output. But what about these signal? Let's say this is the inverted signal of S1, name is S1N, and S0N is the inverted signal of S0, and Y0, Y1, Y2 and Y3. So we need to declare all these signals, all these 6 signals, right? So can declare like wire S1N, S0N, wire Y0, Y1, Y2 and Y3. That's it. Now we need NOT gate instantiation. So you can see this diagram has 2 NOT gates, right? So we need to instance all these gates including these 2 NOT gates. So NOT, instance name is, you can see A1. After that, first of all just declare the output, right? So let's say I am talking about this gate. So the output of this gate is S1N and the input is S1. So we can declare like S1N and input is S1. Similarly for this gate, the output is S0N and the input is S0. Okay, so let's take some another name, and that is S0N and input is S0. That is enough for the NOT gate. Now AND gate instantiation. So let's write AND A1. Guys, you can see it has 4 AND gates, 1, 2, 3 and 4, right? So first of all we need to declare the output, after that the input of the selected gate. So input is I0 and that is S1N, and another input is S0, right? So we can declare like first of all the output, that is Y0, after that the input, so in of 0, after that next input is S1N and next one is S0N, right? Just copy paste and modify the functionality. Now I am talking about this gate. So output is Y1, input is I1, another input is S1N and another input is S0N. This is S0, right? So Y0 in 1, S1N and S0. Similarly for next gate, that is A3, y2, it becomes input 2 and S1 and S0n. For next gate it will become A4, y0 is output is y3 and input is in 3 and it will become S1 and S0, right? So till now we have done with these two AND gates and these these two NOT gates and these four AND gates. Now we have to write a code for this OR gate. So this OR gate have a one output, that is out, and 4 input, that are y0, y1, y2 and y3, right? OR gate instantiation. So OR so first of all we need to declare the output, that is out. After that y0, y1, y2 and y3. That is enough. We have done with the RTL code of 4:1 multiplexer, right? Now we need to declare the test bench, right? Because we also need to verify the functionality of this RTL code. So module, let's say module name is TB and module declare all the output as wire type, so it has only one output, right? So wire out, and all inputs should be reg type. So reg 3 down to 0 in. Another input is our select line, so S1 and S0. Now just connect the port. So first of all we need to declare our module name. So module name is mux4_1, right? So mux4_1, take some instance name, that is, let's say DUT, you can take any name, right? After that out and in, after that S1 and S0. That is enough. Inside initial, begin, end, we need to declare the all combination of the inputs. So first of all, let's say my in is equal to 3 tick B 0000, right? And my S1 is equal to 1 tick B0 and S0 is equal to 1 tick B0. Give some small delay, let's say #1 and dollar display in is equal to %B, and can also write for out. So okay, first just declare all the inputs. So in is equal to %B, S1 is equal to %B, S0 is equal to %B, out is equal to %B, right? Here you can write in, after that S1, S0 and out. That is enough. So we have given a input, that is 0 0 0 0. That means I0 is equal to 0, I1 is equal to 0, I2 is equal to 0 and I3 is equal to 0, and S1 is also 0 and S0 is also 0, right? Now for the same values of input, or I0, I1, I2, I3, just change the select line. So let's say now it becomes 0 1, right? In next case it becomes 1 0. In next case it becomes 1 1. So now up to this point we have checked our output, means not checked yet, we have write a code when select lines becomes 0 0 0 1 1 0 and 1 1, but the input is same, right? So now let's say I want to change the input. So okay, now just change the value of your select line. Now let's say here your select lines become 1 for all the combination of S1 and S0. Similarly, you have to write the select line 2 for all the 4 combinations. Similarly, select line should be 3. Similarly, 4, right? So you can see the code becomes very huge. So okay, first we need to check this code, whether it is working or not. After that, we will see some advanced approach to verify the behavior. It is giving some error. Let's see, 13 and 14. It is saying A1 and A2 is already declared. Okay, because we already declared, so we can change here N1 and N2 actually. It is my mistake, because we here declared the instance like A1, A2 and A here also. So we need to change that actually, N1, N2. Now we can see our output, that is our when select line is 0, so it will pick the value of this I0, that is 0. When it is select line is 1, then it will take value of I2, that is 0. Similarly, select line is 3, so it will take the last value, right? Now you can see my select line is 1, my input is 1 and select line is 0, so it will take the value of I0, that is 1, right? Similarly, my select line is 1, so it will take the value from I2, that is 0, like that. So it is working fine, but the drawback is I have to write all these combinations. Still it is all combinations are not covered, right? So it will consume your multiple lines, and it is not a very good verification approach. So we will see some advanced method to avoid all these things, to write all the combination again and again, right? Advanced approach. So for that, just write the same code, module TV and module, just declare wire type out, reg type 3 down to 0, that is in, reg type S1 and S0. After that, module connections, so mux 4 underscore, I think mux 4 underscore 1, take some instance name. Let's say my instance name is DUT, and just pass all these things. So out in S1 and S0, right? After that, write initial, begin, end. So up to this point all things are same, right? Now what we have to do, we will use some loop. Let's say repeat 5. begin and inside that. So now see, it has what are the inputs. So it is the input and S1 and S0 is also the input. So we can use the method in is equal to $random. Similarly, S1 is equal to $random and S0 is also is equal to $random. So after that, just give the small delay for the display and write $display. Can directly copy paste actually. Right. So what it will do, it will randomize the value of inputs, right, all the 4 combination, and it will randomize the value of S1, that is a single bit. That means maybe sometime it is 0 and another time 1. Similarly for S0. So now just try to use this to verify the behavior of the same. Now we can see 1, 2, 3, 4, 5. 5 times it is giving the randomized value because we use 5 inside the repeat loop. That was okay. So our first combination is 0, 1, 0, 0. That means I0, I1, I2. I2 is 1, right? But my select line is 1, 1. That means it should be I3. So what is the value of I3? That is 0. So out is 0. Here select line is again 1, 1. So what is the value of I3? That is 0. That means output is 0. Correct. Next one is my select line is 0, 1. Right. So what will be the value? That is I2. That is 0. Again correct. Now select line is again 0, 1. So it will take output as I2. So I2 is 0. Again correct. Now select line is 0, 1. So it will take again I2. Right. So it is not giving 1, so let's increase the frequency of this loop. Let's say 15 times I am running. Now you can check any randomly. Here you can check S1 is 1, that is 0. So it will take the value of I2, that is 1. So output is 1, right? Again it is 1, 0, right? So 0, 0, 0, 1, 1, 0, that means I3 value, right? Again it is 0, 0, 0, 0 means I1 value, that is 1. So output is 1, right? So you can check. So it is working fine. Our code is correct, right? So now come to the next point, that is 5.1.3b. It is 1-bit full adder. So just write a code, module full adder and module, right? Now you can see this is our 1-bit full adder. So it has A, B and C in as the input, and our output is sum and C out or carry, right? So declare this port name sum carry. After that A, B, C in, right? Now declare output. So output is sum and carry. Input is A, B, C underscore in only, right? Now we also need to declare the internal variables. So we can see in the diagram it has some internal variables, S1, C1 and S2, right? They are the internal connection between gates. So wire S1, C1 and S2. Now come to the gate instantiation. So it has one XOR gate. Here it is AND gate, again XOR gate, AND gate, and then final XOR gate, right? So in the same way as we have written the code previously of 4 cross 1 mux, we have to write. So let's say XOR, instance name is X1. So what is the output? Output is S1 and input is A and B. So output is S1, input is A and B, right? Next gate is AND gate, functional instance is A1. So for this AND gate, output is C1, right? And input is A and B. C1, A and B, right? After that again XOR gate. So let's take X2. Here you can see the output is sum and input is S1 and C underscore in. So sum S1 and C underscore in. Next gate is AND gate. Let's say instance name is A2. So output is S2 and input is this is S1 and this is C in, right? So S2 input is S1 and C underscore in. Now it's turn to write the final gate, that is XOR gate. So use X3 and you can see the output is carry and input is S2 and C1, right? Carry and input is S2 and C1. That's it. We have done with the RTL code, right? Now let's write the test bench. So as we have written the test bench in advanced approach, the same way we will follow to write this test bench. So module TV and module declare the input and outputs. So input should be res type. So res A, B, C in, and output should be wire type. So wire type is out and carry. After that the module name, that was full adder DUT. Inside that sum carry A B, C in. Initial, begin, end. Inside that just use like repeat 10, begin, end. Just write what are the inputs. So first of all, A is equal to dollar random. Next input is B is equal to dollar random. Next one is C is equal to dollar random. After that give some small delay, #1 and some display statement. A is equal to percentile B, B is equal to percentile B, C underscore in is equal to percentile B. So it is actually C underscore in. After that sum is equal to percentile B and carry is equal to percentile B. Now A, B, C in, sum, carry. That is enough, and we have done with the test bench. So as you can see, A is equal to 0, B is equal to 1 and Cn is equal to 1. So sum is 0 and carry is 1. Similarly, when A is equal to 1, B is equal to 1 and C is equal to 1. So sum and carry both is 1. So it is working fine, right? So we have done with the single bit full adder. After that, come to the next topic. That is 5.1.3 C. Here we will learn what is module instantiation. So we will see what is module instantiation, what is the application, how we can use, right? We'll design 4-bit ripple carry full adder using single bit full adder, as we already done with the here single bit full adder, right? Now we will use that code also inside this code. So first of all, let's write like module name is, let's say, full add, and inside that sum carry A B, B and C underscore in. And module inside that input is A, B, C underscore in, and output is sum carry. Now we need to also declare the internal variables, right? So actually this is the same code what we have done over here, right? So let's copy paste actually. This is the same code what we have done earlier, right? But now because we have to design 4-bit ripple carry adder using single bit full adder. So first of all we need the code of single bit full adder. This is the single bit full adder code, right? And now write again module full, let's say add 4-bit and module, and just write the port name, let's say sum C underscore out and A, B, C underscore in. Here just write like output 3 down to 0 sum output C underscore out and input 3 down to 0 A, input 3 down to 0 B, and single input, that is C underscore in. So this is the block level idea. So this is the full adder code, this block. So we already have the full adder code. So we need to call this full adder code up to 4 times, because 1, 2, 3 and 4, right? And we have declared all the vector form as A0, A1, A2, A3. So we have declared A3 down to 0. Here another input is V0, V1, V2, V3. So we have declared B3 down to 0, right? And we also declared sum 3 down to 0 because it will give 4 sum. Sum 0, sum 1, sum 2 and sum 3. Single carry C in is the input and single output carry C out is the output, right? So we have done with that. Now we also need some internal variables or connections, right? So we need to declare it as a wire. Now what are the wires? You can see that is C1, right? Next one is C2 and next one is C3. So just declare C1, C2 and C3, right? After that, now we have to call our 1-bit full adder code and give the output as A0, B0 and C in, and input as A0, B0, C in, and output will be C1 and sum naught, right? So our single bit full adder module name was full adder, right? So just write the same name. Means what is the conclusion? We can use it as a single gate. We can consider it like a gate, the same thing, right? So that is called module instantiation. Actually here full header, let's say handle name is FA underscore 0, and here I am passing sum of 0, not passing, I am writing actually, and output is as you can see in the diagram, the output is sum 0 and C1. So output is sum 0 and C1, and input is A0, B0 and C in. So we can also mention A0, B0 and C in, C underscore in, right? In the same way, it will become 1, it will become 2, it will become 3. So for next block, the output is sum 1 and carry output is C2. So it will become sum 1 and carry will become C2, and what are the inputs? A1, B1 and C1, right? So A1, B1 and C1. C1 nothing but our internal connection, as we can mention, as already mentioned over here, right? Similarly for next, for this block, output is C3 and sum 2. So sum 2 and it is C3, and input becomes A2 and B2, right? Now come to our last block. The output is C out and sum 3. So it is sum 3 and that is C underscore out, and inputs are A3, B3 and C3, right? So A3, B3 and C3. That is enough. We have done with the RTL code, right? Now we have to write the test bench. Module TB and module declare all inputs as a reg type. So reg 3 down to 0 A, reg 3 down to 0 B, reg C underscore in, output should be wire type. So wire 3 down to 0 sum, and another output is carry, right? So we have declared carry as a C out actually. C out, right? Now just use the module name of the ripple carry 4-bit adder, that is full underscore add underscore 4-bit, take some instance name, that is let's say DUT, and just pass some carry A, B, C in, and that is enough. So it is actually C underscore out. After that initial begin, and inside that use some loop, let's say repeat 10 begin end, inside that A is equal to $random B is equal to dollar random and C underscore in is equal to dollar random. Give some small delay and dollar display, and inside that A is equal to percentile B, B is equal to percentile B, and C in is equal to percentile B, sum is equal to percentile B, carry is equal to percentile B, right? Here A, B, C in, sum, and our carry is actually C out. That is. So now just copy from here, because otherwise it will not get the definition of full adder what we have used over here, right? So guys, as we can see, it is randomizing all the values and giving the output, right? So here it is 1 0 0, and B is only 1, C is also 1, and sum is this 1 0 1 0, carry is 0. So you can check with calculator accordingly, right? So we have completed that point. So coming to the next topic, that is point number 6. Data flow modeling. So first of all, we will see what are the benefits of the data flow kind of thing. So actually, for a small circuit, the gate level modeling approach actually works well, because number of gates is limited. Designer need to initiate and connect each gate in complex circuit. The number of gate gate count is very high actually. Data flow modeling provides a powerful way to implement a design, right? Next point is Verilog a circuit to be designed in the term of how data flows between registers, right? So now we will see the subtopics of data flow modeling, right? So come to the 6.1, that are continuous assignments. We will see what they are. Most basic statement in data flow modeling. Used to drive value on nets, or can say wires. Both are same actually. If we need to declare a net, then we should use the keyword wire, right? This statement starts with keyword assign, right? Now come to the next topic, that is 6.1a. So we will see the rules to use assign statement, right? So the left hand side often assignment or assign statement should be scalar or vector net or concatenation of scalar and vector nets, right? The next point regarding assign statement is it can't be concatenation of vector register or scalar, right? Next point is LHS updated immediately when RHS side change its value. The RHS may be register, net, also function call. These register can be scalar or maybe vector, right? So this is all about the assign statement, and now we will see the coding part of assign statement later. Now first we need to cover our next topic, that is operator types. So 6.2 operator types. So subtopic is 6.2.1, that is arithmetic operator. So we will see, we will try to understand this operator using one example, right? So it has various kind of operator. One of them is arithmetic operator, and arithmetic operator again has some sub functionality further divided into 6.2.1.1, that is called binary operators. Now we will try to understand what are the binary operators using an example. Let's write simple module. Module name is, let's say, binary ops. And module inside that just declare integer type A, integer B, and another variable that is out, right? Now initial, begin, end. Inside that just initiate some value, let's say A is equal to 20 and B is equal to 20. Now give some delay, let's say has 1 nanosecond, dollar display. Let's say I want to check first addition, so can write addition is equal to %0d, or you can write %d, both are same actually. A is equal to %0d and B is equal to %0d. So we want to print the addition, so we can directly write here A plus B actually, or we can do one thing, we can write out is equal to A plus B over here and we can print the value of out. Both things are okay. A and B, right? Now again right, let's say A is equal to, now A is equal to 10, take some another value, and let's say B is equal to 5. Okay, give some delay, #1, and you can write multiplication. Multiplication is equal to %0d, A is equal to this, B is equal to this, and just change this sign to asterisk, that is used for multiplication, right? Again change some value, let's say A is equal to, again okay, A is equal, let's say 10, and B is equal to 20, right? Give some delay, #1, and you can write for subtraction. And here just change that sign to minus, right? Now again can change, or we can continue the same value, that's not an issue. A is equal to, let's say, minus 15, and B is equal to, let's say, 5. Give some delay, #1, and now let's try for division. And change the sign, let's say A divided by B. So this sign slash, actually it is used for division. Now just copy the same thing, 1 2 3 4, and paste over here. Now let's say take 15 as a positive and 5 as a negative, and just check for the division, right? Again can do one thing, you can take both as negative for your better understanding, right? Now we have done with the division. Now let's come to the modulus. So for modulus, let's take A is equal to 10, B is equal to, let's say, 3. Give some delay, #1, can write mod, and here we can give A percentile B, so it will give modulus, right? Now again we can try some more operation for the modulus. Now take it as a negative number. Again for the same modulus, take it this, the second operand, as a negative number, and again for the modulus take it both number as negative, right? Now let's change again the value, let's say A is equal to 5 and B is equal to 3. Give some delay, now we will check the power. So to check the power, you should use double asterisk. It means A raised to the power B, right? So we have done with this code of binary operators. Now run it. Now you can see A is equal to 20 and B is equal to 20, so addition is 40, that is correct. A is equal to 10 and B is equal to 5, multiplication is 50, that is correct. Now A is equal to 10 and B is equal to 20, and we are performing A minus B, so subtraction is minus 10, that is okay. Here A is equal to minus 15 and B is equal to plus 5, so division is minus 3, right? It will give the minus sign. Again A is equal to 15 and B is equal to minus 5, right? So division is minus 3, okay. After that A is equal to minus 15 and B is equal to minus 5, so it will cancel the minus sign and division is 3, right? Now A is equal to 10 and B is equal to 3, so mod is 1 because 1 is the remainder, okay. 3 3s are 9 and 1 is the remainder, that is your modulus value. Now A is equal to 10 and B is equal to 3 for the same value, because it is a minus sign, so it will give minus 1. But in case of a is equal to 10 and b is equal to -3, it will take the first operand sign. So first operand sign is positive, so that's why it is giving positive sign, right? And here both operands are negative. A is equal to -10, b is equal to -3, so it will give -1, not +1 like your division, right? So this is the difference. Sometimes they are in the interview, right? Now a is equal to 5 and b is equal to 3, and we are performing a raised to the power 3, that means 5 raised to the power 3 actually, so that is 125, right? So this is how we can use the binary operators, right? Now our next point is 6.2.1.2, that are logical operators. Can evaluate only one bit value, may be 0, 1 or x. So let's write code. So module top and module integer a, integer b, integer c. Initial, begin, end. Let's say a is equal to 10. Just initialize some random values. Let's say b is equal to 5 and c is equal to 0. Okay, give some delay, #1 dollar display a and then b. Okay, that means we are using double AND, so that means we are performing logical operations, right? So a and then b is equal to percentile b. A and then b is equal to, let's see in decimal, percentile d, and a is equal to percentile d, b is equal to percentile d. Here just write a and then b, a, b, right? Now just do the same operation with c, a and then c. Right? Okay, give some delay. No delay actually, it is just for GUI purpose actually, so that we will able to see the result in a good way. There is no need, means the chances to be confused is less, right? Again, let's perform the same operation 2y by p for OR operator. So a is equal to d, sorry, a is equal to percentile d, b is equal to percentile d, a or b, and now perform the same with c. Right? actually what we are doing in this display, it will print the same line at is. Okay, so actually we want to see in the separate section, that's why I use the dollar display like this or like this, right? So now write one more dollar display. Let's say I want to perform note operation. So for that we can write note of A is equal to percentile D, and let's say note of B is equal to percentile D, note of C is equal to percentile C. Here we can write A, B, C with note actually. We have done with that. So our A was 10 and B was 5. So A and B is 1, right? It is performing the ANDing operation. For better understanding, you can convert it to the binary values, right? Here A is equal to 10, C is equal to 0, right? That means what it will check, actually AND operation here, whatever we are performing the logical operation, so it will check only for true values. So if you are not convert into the binary, that also okay. You can see it is a non-zero value. 10 is not equal to 0, B is also not is equal to 0. So when you perform A and B, so it will give true, that means high. Here C is false value or 0 value and A is true value, right? So when you are multiplying, performing AND operation with true and with false, so it will give false, right? Similarly, for OR operation, A is equal to 10 and B is equal to 5. So both values are high. So it is giving high as output. Here, one value is true, one value is false, right? One value is high, one value is low. So OR gate will give high as output, right? Because we know the functionality of OR gate. If any input is high, output should be high. Here it is. And in NOT gate, if any input is 0, output will be 0. The same way it is performing. And here, note of A. So A is the non-value, means non-zero value, means true value. So the invert of true value is false, that is 0. Similarly for B. B is our, what is the value of B is 5. You can see over here or over here. So it is a true value. The NOT operation of B is 0, and it is not printing the value of C. Let me check. Okay, it is actually percentile D over here. So now the value of C is false always, right? So the invert of the false is true, that means high value, right? So we have done with the logical operators. Now let's come to the relational operators. That will be 6.2.1.3. Will result high or 1 if expression is true, and 0 if expression is false, right? Next point is if any operand is X or Z, then output will be X only, right? It will not give Z. So let's write a code to understand the behavior. Module top and module, let's say reg, take some width, okay, 7 down to 0, that is data 1, reg 7 down to 0, that is data 2. That is enough. Initial, begin, end. Inside that, let's say my data 1 is equal to 10 and data 2 is equal to 9. Hash 1, give some delay, dollar display, output for, let's say data 1 is greater than data 2 is equal to percentile 0D, right? And data 1 is equal to percentile 0D, data underscore 2 is equal to percentile 0D. Here data 1 is greater than data 2 and data 1, data 2. So what we are doing, actually we are performing a check. We want to check whether this statement is correct or not. Means if data 1 is greater than data 2, if this statement is right, then it will give high as a output, else it will give low, right? As I write over here. Okay. Now for next operation, let's say this is equal to also 10, right? And we are performing the same, right? For next operation, let's say it is 5 and it is 10, and I want to perform the data 1 is less than data 2, right? For next operation, we have checked with like 10, 9, 10, 10, 5, 9, 10, 9, right? So okay, for next operation, just use like let's say tick bx, and it is, let's say 10, and we are performing like this, whether data 1 is greater than data 2 or not, right? And in next operation, let's say I am declaring it as tick b chat, right? And it is 9, and I am performing this operation. Now let's say one more combination. Now 1 becomes x, tick b x, and it is become z, tick b z, and I am performing some operation, right? So we have done with the code of relational operators. because now you can see the output. My data 1 is 10 and data 2 is 9, and I am checking whether data 1 is greater than data 2. Yes, 10 is greater than 9, that's why it is giving high. Okay, now my both data 1 and data 2 both are 10, and I am checking whether data 1 is greater than data 2. No, because they both are equal, that's why it is giving 0. Now data 1 is 5 and data 2 is 9, and I am checking whether data 1 is lesser than data 2. Yes, 5 is lesser than 9, that's why it is giving high. Now data 1 is x and data 2 is 10, so output is x. I am checking whether data 1 is less than data 2, but we don't know the value of x, that's why it is giving x. Again, data 1 is z and data 2 is 9, so again I am checking data 1 is less than data 2, it is giving x, right? And my data 1 is x and data 2 is z. In the same case, if I am performing whether data 1 is greater than data 2 or data 1 is greater than data 2, it will give x, right? So as I have mentioned in two statements, please go through them, right? Now come to the next topic, that is 6.2.1.4. They are equality operators. Now we will see what are the equality operators. Let's say A is equal to B. It means A equals to B. Result is unknown if x or z in any operand. What is the mean? It will check the value, but A is one operand, B is another operand. If any of operand have any value of like x or z, then result will be x or unknown, right? Next operation is A is not equal to B. So it will check whether it is equal to or not, and it means A not equals to B, and result will be unknown if x or z in any operand, right? Next is A triple equal to B. That means A equals to B including x and z actually. Next is A not equal to double equal to B. It means A not equals to B including x and z. Now we will see that thing by an example. We will try to understand. Okay. Let's say module top and module integer A is equal to, let's say, 10, integer B is equal to, let's say, 5. Now take some reg, let's say 3, okay, 4 down to 0. Let's say x is equal to 4 tick B 1 0 1 0. Okay. Take another resistor as y is equal to, let's say, 1101. Y, it is z. Don't get confused, they are x, y, z, just the alphabet. Don't get confused with x with this x, means don't care x or z with this x or high impedance, right? So z, let's take 1 and xx z. These are the don't cares, and this z is for high impedance, right? So this z and this z is always this is just alphabet or variable name, right? One more variable, let's say m, and its value is 1 xx z. Let's say another variable n, and take the value is, let's say, 1 triple x. Initial, begin, end. Dollar display. Let's say I am checking A double is equal to B, right? A double is equal to B is equal to percentile COD, and here A double is equal to B. That is one thing. In next statement, let's say I am checking A is not equal to B. In next statement, I am checking, let's say x is equal to z. So x z. In next one, I am checking x is not is equal to z. In next statement, I am checking m double is equal to z. In next one, I am checking, okay, m do one thing, triple equal to z, and in next one I am checking n triple equal to z. In next one I am checking, let's say m not double equal to n. That's it. Okay. So now first I am checking for A is equal to B, right? So A is 10 and B is 5, and I am checking A double is equal to B, it is giving 0, that means no, false. Again I am checking A is not is equal to B, it is saying yes, true. Again I am checking X double is equal to Z. The value of X is 1010 and the value of Z is 1xxz, right? So because X double is equal to Z, so it has some unknown values. You can see in Z, where it is Z, yeah, it have unknown values and one high impedance value, right? So while I am trying to perform this operation, X double is equal to Z, it is giving X, and while I am performing x is not equal to z, and z has some unknown and high impedance value, it is giving same x unknown, right? Now I am writing, I am checking m triple equal to z. So now you will able to understand the difference between double equal to and triple equal to. So the value of m is xxz, and the value of z is where it is 1xxz, right? So these values are same. So while I am performing m triple equal to z, it is giving 1, right? Now because it will while I am doing triple equal to, it will also compare for x and z. Only this is the only difference between double equal to and triple equal to. Now I am checking n triple is equal to z. So where is n? N is this and z is this, right? So it is giving 0. Why it is giving 0? Because n has this x, but it has n, and z has the LSB as z, but n has x. So it will not compare x and z. So that's why it is giving 0, right? In last I am comparing, m is not equal to n. So you can see m has xxz, n has triple x. So it is giving high. Why? Because the LSB of m is z and the LSB of n is x. That's why it is giving high. That means they are not equals to, right? So we have done with equality operators. Now next topic is 6.2.1.5, that are bitwise operators. So let's write a code. Module top and module, inside that range 3 down to 0. Let's say x is equal to 4 tick b 1010. Let's take another variable y, and let's take 1101. Let's take another variable name is z, and take 10, okay, take x and 1. Initial, begin, end, dollar display, inside can perform like this. That is called tide sign actually, right? Also it is performed actually not operation. So x is equal to percentile b, and here you can write like this, x. Now dollar display, we have checked for the x. Let's write x and y is equal to percentile b, here x and y. Next one is x or y is equal to percentile b x of y. Next one is we have performed not operation, and operation, or operation. Let's say x XOR. So XOR sign, we should use that cap. We want to perform, if we want to perform XOR operation in Verilog, right? So x XOR y. Now we have only okay, come to the XNOR. So x tide sign and cap sign, that is for XNOR operation, right? is equal to percentile B. So X and X naught with Y, right? Now do one more experiment with X and Z actually. So let's say X and Z is equal to percentile B. Here I am writing X and Z because we initialize Z with one X value, one known value, right? So we will see what will be the output. So first we perform NOT of X. So the value of X was 1 0 1 0. So 1 become 0, 0 become 1, this 1 become 0, and the LSB side 0 become 1, right? It have invert all the bit positions, right? After that X and operation with Y. So you can see this is X and this is Y. So this is 1 and 1. So 1 and 1 the means and operation of 1 and 1 is 1. So that means it is 1, and 0 1 that is 0, again that is 1 0, so 0, again that is 0 1, so 0, right? Because for AND operation if we want output as high, so all the inputs should be high. So in this case only this case means MSB side only high, that why it is giving 1 and rest of bits are 0. Now OR operation between X and Y. So 1 plus 1 that is 1, 0 or 1 that is 1, 1 OR operation with 0 that is 1, 0 OR operation with 1 that is 1. That means it is also correct, this one, right? Now the XOR operation. So this is the XOR operation between X and Y. So XOR will gives always the high input, high output when it has different input. For the same input it will give 0. So 1 1 it will give 0, right? And it is different 0 1, so it will give high, 1 0 it will give high, 0 1 it will give high, right? And XOR will perform the just reverse of that XOR operation, right? Now our last one is X and operation with Z. So this is our X and this is Z. So 1 and 1 we are performing AND operation, so output is high, right? 1. Here it is 0 and it is 0, so output is 0. Here for this bit it is 1 and it is X, that means output will depend always upon X. If it is the value of X is 1, so output will become 1, 1 and 1 1, and if the value of X is 0, so 1 and operation with 0 will become 0. So always the output will depend the X, so that why it is giving X, right? And 0 and operation with 1 that is 0, right? So we have done with the bitwise operators. So in bitwise operation or when we use bitwise operator, so it will perform the operation bit by bit, right? Now coming to the next topic, that is 6.2.1.6, that is reduction operator. Let's say module top and module declare let's say reg 3 down to 0x and initialize some value like 4 tick b 1010 and initial begin end. Inside that dollar display we can write like and x is equal to percentile 0b and x. Okay, and x. Now just write this operation not of x and we will see whether they are same or not, right? Next one is just perform with OR operation, that is for OR operation, right? Next one is for XOR operation. And the last one is for XNOR. That's it. So we have given the value of x is 1010. So what it will give, what it will do, it will perform the AND operation between these bits. That means 1 AND with 0, that is 0, 0 AND with 1, that is 0, and 0 AND with 0, that is 0. So it is 0, right? So they are called reduction operator. So they will give single output, single bit output always, right? Now I am performing, I have used this not sign, right? So it is also performing the same operation as we have done with the AND operator, right? Now for here, this is the OR operator. So 1 OR with 0, that is 1, 1 OR with 1, that is 1, and 1 OR with 0, that is 1. So it will give 1 as output. Now XOR. So for XOR, 1 and 0. So XOR will give high than for different bits. So 1 and 0, that is high. So it will give 1, 1 and 1, that is 0, 0 and 0, that is 1. Sorry, that is for XOR operation, right? And XOR is just a reverse of this XOR operation, right? So it will work actually means 1 by 1 bit. That's why they have only single operands. Okay. Now coming to the next operator, that are shifting operator. So they are 6.2.1.7. Shift operator. Let's say module top and module reg 3 down to 0. X is equal to, let's say, 4 tick B 1 1 0 0. Next one is reg, let's say 3 down to 0 Y. Let's take, I think that is enough. If we needed if we need some more variables, then we will add accordingly. Initial, begin, end. So first of all we will perform, okay, just write let's say by is equal to x double right shift by 1, right? And dollar display can write by is equal to percentile 0b that is y. So what it will done, right shift by 1 bit and MSB filled by 0, right? Now okay, let's do it 2. So it will shift, right shift by 2 bit and MSB filled with 0, right? It will perform left shift by 1 bit and it will perform left shift. Let's take it 2. So our value of x is 1100 and we are doing right shift by 1 bit. So what happens, the all these bits will be shifted to here, means it will be like this 0 will shift to the this position, this 1 will shift to the 0 position and this 1 will shift to the this 1 position, right? So it is 1 1 0 and it is not giving here 0 because MSB side 0 is nothing, right? Now I am performing 2 shift. So now my output is this 110. So when I am performing 2 shift, so not actually we have used actually by, so for the same value for 2 shift, so this 0 will shift over there, this is the 1 shift, this 0 will replace this 0, 1 will come to the this position and this will come to the 1 position. This is single shift. Again because we are shifting by 2 position, so they both will 0 vanished and the 1 will replace the position of the 0, right? So it will be like output will be 0 0 1 1. So it is not giving 0 at MSB side, that is totally okay. Similarly for left shift, right? For left shift, let's say this 1 will be vanished away and value will be 1. This 1 will be shift to the MSB side and 0 over here, this 0 over here, and it will fill this position MSB with, sorry, LSB with 0. So that why it is giving 1 0 0 0. And while we are performing 2 times left shift, so both 1 will be vanished and filled with MSB side with 2, LSB side with 2 additional zeros, right? So till now we have done with the shifting operation. Now come to the next topic, that is 6.2.1.9, 1.8 actually, that is concatenation. Module and module, and let's take reg A is equal to 1 tick B1 reg, let's take 1 down to 0 B, and is equal to, let's take 2 tick B 0 0. Next one is reg 1 down to 0, that is C, take 2 tick B 1 0, reg 2 down to 0, that is D, 3 tick B 1 0 0, okay, or take 1 1 0. Now can write initial, begin, end, dollar display B and take a C and take D, okay, is equal to percentile 0 B. Here you can write like this, B C D, B C D, right? In next display, let's write A, C, and take some square bracket, take only one bit, that is okay, let's say C1, and D, let's take D0, is equal to percentile 0 B. Here can write like A comma C of 1 and D of 0. So what is concatenation means? You are binding something, means these are the variable B, C, D. So value of B is this, C is this, and D is this. So while you are doing like this inside curly braces and put the variable with comma, so it will concatenate all these values, right? So it will give output like 0 0 1 0 1 1 0. It will convert it, bind it to the single value, means single location value actually. And similarly it will take the value of A, whatever the value of A, after that the value of C1. So at first position value of C1 is 1 and D not, so D 0, so 0th position value is 0, like that. So for BCD, right? Yeah, BCD. So value of B is 0 0, value of C is 1 0, D value is 1 1 0. So it will give 0 0 1 0 1 1 0. It is not showing 0 0, it is giving just 1 0 1 1 0 because 0 0 is MSB side. Okay. So MSB side 0 0 means nothing. Similarly, it is giving value for this A. The value of A is 1, that's why it is giving 1. After that the value of C1. So the first position C value is 1, that is it is giving 1. And the D at 0 position, it is 0. So that is it is giving 1 1 0. So they are working, they will work like that. So now come to the next point, that is 6.3. Conditional operator, right? So let's see few points about them. Takes 3 operands. Can be compared with if-else ladder actually. And now let's see the syntax. Syntax is like result is equal to conditional expression true expression and here false expression. We will try to understand the syntax via small code, right? So let's write a small example of multiplexer. Let's say module mux and module and just tell there input like I0, I1, because it have only two inputs and one select line, that is S, and one is output, right? So input is I0, I1 and S, output is out. So we know the functionality of 2 cross 1 mux. Let me explain you. That means, let's say I have one block, and inside block this is your 2 cross 1 mux, and it has one select line, that is S, one is your output, that is out, and has two input, that are I0 and I1. So what happens when the value of select line is 0? So at that time out should equal to I0, right? And when the value of select line is 1, so out should equal to I1. This is the functionality, right? So how we can implement this condition using conditional operator, we will see, and also we will try to understand the assign statement, as we have discussed earlier in this chapter, right? So let's write assign out is equal to, so now compare whatever I am going to write with this statement. Now your result is out is equal to conditional expression, right? So what is my conditional expression? Conditional expression is my S naught, right? So I can write not S naught, that is S. After that this, the question mark, right? And after that true expression, false expression. So let's say my value of S is true, so it will give I1 as the output. So just write I1, and after that colon, if the value of S is false, it will give I0 as output. I0, right? That is enough. We have done with the RTL code of 2 cross 1 multiplexer, right? So this is the way how we can use assignment operator to design the functionality of some RTL code, right? Now let's see one more complicated, somehow complicated code of 4 cross 1 mux. Let's say module mux and module. Now 4 cross 1 mux have 4 inputs, so I0, I1, I2 and I3, 2 select line S0 and S1 and 1 output, that is out. Input is I0, I1, I2, I3. Another input is select line, that is S0 and S1 output is out. So now how we can write the assign statement using conditional operator in this case, right? So let's say assign out is equal to, first of all let us draw a block diagram of that multiplexer. I think we already have that one. Yeah, this diagram is enough. So you can see when the value of S1 is 0 and S0 is 0, so the output is 0, sorry, I0, right? So it means that is S1 bar, that is S0 bar, and output is I0, right? So if you know the binary expression for that, you can easily write the code, right? So it will be like, if you come to this point in this diagram, so you will able to know what will be the output, right? So it will be like S1 naught means this, naught of S1, and this means S1n and S0n and I0, right? The input of this gate, it will, what will be the value of Y0? That will be I0 and operation with S1n and operation with S0n, right? Similarly for by 1, similarly for by 2, similarly for by 3, and they will be input to the OR gate. So it will be like this, means not of S1 and not of S0 and I0. Right, OR operation with, so I am using this operator. For next expression, it will be not of S1 and operation with S0 and operation with I1. You just need to follow this diagram only, right? Using this diagram, what will be the values over here? You can write one expression for this, second for this, third for this, and fourth expression for this. After that, just perform the OR operation. So I am doing the same. This is my first value, this is second value, and similarly I will write third value and fourth value for each AND gate, and after that I am performing this OR operation, right? Hope now it's clear to you. S1 and operation with not of S0 and operation with I3, sorry, I2. After that, OR operation with S1 and S0 and I3. Let me check once. Here it is 0 0, here it is 0 1, here it is 1 0, here it is 1 1. I0, I1, I2, I3. Yeah, that is absolutely right. So this is just using with assign operator. I am not, I didn't use any ternary operator or conditional operator. Sometimes it is also called ternary operators in C language. In Verilog, it is called the conditional operator. So in this statement, I never used the ternary operator or conditional operator, right? So now just write a test bench to verify the behavior. So it is using assign statement. Module and module can declare reg I0, I1, I2, I3, Similarly for S0 and S1. Wire that is only out, because mux always have single output. After that, mux instance name is DUT. Let's write I0, I1, I2, I3. After that, S0, S1, and out. Now, initial, begin, end. Just use repeat 5. Begin, end, and use I0 is equal to $random I1, I2, I3, S1, and S1 and S0. Right? Now give some delay #1 and $display. You can print all these values, like I0 is equal to percentile B, I1 is equal to percentile B, I2 is equal to percentile B, I3 is equal to percentile B, S1 is equal to percentile B, S0 is equal to percentile B, and out is equal to percentile B. So just write I0, I1, I2, I3, S1, S0, and out. Right. Now just try to run this code. There is some problem in, I have written byte, it is actually wire, it is a typing mistake. Now you can see here the value of select line is 1 1, that means it will select the final value of I3 as output. So you can see this is 1, this is 1, this is 0 1, that means it will select the value of I2. So I2 value I0, I1, I2, I3, 0 1, so I0, it will select the value of I1, so that is 0. Similarly, when it is 1 0, so it will select the value of I2. So this is I2, the value output is 1. Similarly 0 0, so for 0 0 it will select the value of I0, so I0 value is 1, so output is 1. And for S1 0, right, so 1 0 it will select the value of 0 0 0 1 1 0, that means I2. 0 0 0 1, sorry, that is 1 1, right, so 1 1 is for I3, so it is giving out as high, so it is working fine, right? Now we will try to implement the same code, same RTL code using conditional operator. So we will modify this code actually. So just copy paste. Not using we will also use then using conditional operator. And we will see the difference. So now come to the bulk label diagram. Now there is no need for that here. So now we will we will try to implement the code accordingly with the truth table. When the value of S1, we will check, first of all I will write like this. Out is equal to S1, after that conditional operator, this and this. So here I will write the true, here I will write the false, right? So we will see, because it have condition inside condition. It is not simple as 2 cross 1 multiplexer. So you can see when the value of S1, so when the value of S1 is high, just consider these 2 points. Here the value of S1 is high. So now when the value of S1 is high, we will check the value of S0, right? So here when the value of S1 is high, we will go to inside this true statement. Inside that we will check the value of S0 like this. So when the value of S1 is high, we go to the S0. So when the value of S0 is high, the output is I3, else output is I2. So we will write like this, I3 else I2, like this, right? Now we have read this piece of code when the value of S1 is high. Now let's say the value of S1 is false, that means 0. So we will consider these 2 lines only, right? So when the value of S1 is false, that means 0. So we will check the value of S0. So we can write similarly over here S0, after that conditional operator. So when the value of S1 is false, we should check the value of S0. So when the value of S0 is high, the output is I1. So when the value of S0 is high, the output should be I1, else I0. This is the simple way. Now we have done with this code. The same RTL test bench will work with that. Now let us check the behavior. Now you can see here the value is 1 1, that means it will consider the final value I3 as output. So it is same, okay. This is 0 1, that means 0 0 0 1. So I1, so I1 is 0, output is 0, that is okay. Here it is 1 0, so 0 0 0 1 1 0, that means I2. So I2 value is 1 and output is 1, that is correct. Here S1 is 0 and S0 is 0, that means it will consider the value of I0 as output. So it is 1, output is 1, that is okay. Here S1 is 1 and this is S0 is 1, so it will consider the value of I3 as output. So I3 is 1, output is 1. So that means it is working perfectly, right? We can see one more small piece of code using assign statement. Just take the 4-bit full adder code, right? So let's take one more example for a better understanding. Okay, module. So module, let's say full add, and module full adder, let's say have A, B, C, sum and carry. Because we are performing 4-bit, so let's declare it as vector 3 down to 0, A input 3 down to 0, that is B input C, output sum and carry. Simply line assign. Now you can carry sum is equal to A plus B plus C. That is enough. So we have done with the code of 4-bit full adder. So what we have done, simply we have declared ABC as an input, sum carry as an output. This is a 4-bit, this is also 4-bit, and carry is always single bit, right, whether it is input side or output side. So assign we have written like inside braces carry comma sum is equal to A plus B plus C. We will try to understand what is the meaning of that. We have already discussed the concatenation. So we have performed a operation inside the concatenation. That means while we will add A plus B plus C, so what will be the resultant? It will store to the sum, and what will be the carry? Carry will be always forwarded to the MSB side. So carry will be stored in the carry, right, inside the carry, whatever the value. So in this way we can also write many more code, but I think that is enough using the assign statement and kind of thing. So guys, our next topic is behavioral modeling, right? So let's take it as point number 7. Let's see some few points regarding that. Verilog provides the ability to describe functionality in an algorithmic manner. Means designer describe the behavior of the circuit and behavioral modeling represent the circuit at a very high level of abstraction. Verilog is rich in behavioral construct that provides the designer with great amount of flexibility. Now next point is 7.1, the subtopic. Structured procedures. Initial and always are two structured procedures. Statements in Verilog. Right. The next point is these two statements are basic in behavioral modeling, right? Next one is they always, or can say ever, start at 0 simulation time. Next point is always and initial cannot be nested, right? So let's check initial statement. Let's write a code. Let's say module top and module take some value like reg 3 down to 0 x and can write initial begin end. Inside that we can assign some value to the reg x. So x is equal to 4 tick b, let's say 1011, some small delay, dollar display, and write like x is equal to percentile 0b x, right? So this is how we can use the initial block to initialize the values, right? If we print this code, then it will return the value whatever we initialize over here, right? The next one is always statement. So 7.1.2 always statement. So it is like module top and module. Let's declare some variable like clock, and let's say I want to generate the clock with every 5 nanosecond. So I can write here reg clock is equal to 0, and after that I can write like initial begin end and actually there is no need for that. I can directly write like always #5 clock is equal to not of clock, means #5 is nothing but a delay. So at every 5 nanosecond the clock will toggle its value, as we have used tide sign, right? Clock is equal to tide clock. Sometimes it is also called not of clock, right? So it will toggle always the value between 0 and 1, 1 to 0, 0 to 1. So next point is 7.2, that is procedural assignments. they used to update the values of variable. The value placed on a variable will remain unchanged until another procedural assignment update the variable with different value. So there are two types of procedural assignments. Now we will see the types. So 7.2.1, first one is blocking assignments. Few points regarding that are: blocking assignments are executed in the order they are specified in the sequential block, right? Next one is a blocking assignment will not block the execution of a statement in parallel block. Next point is the equal to sign used to specify blocking statement. Now let's see a code. Let's say module blocking and module. Inside that reg x y, and we'll take z, and reg, let's say 15 down to 0, reg underscore a and reg underscore b. Take one more integer count and initial, begin, end. Inside that let's write x is equal to 0, y is equal to 1, and z is equal to 1. Right, and also write count is equal to 0. Now $display, let's write time is percentile t, count is equal to percentile d, $time count. Now let us declare reg A is equal to 16 tick B0 and time is equal to %LT, and here should be reg underscore A. Now reg underscore B is equal to let's say reg underscore we can also use over here, reg A. After that you can write like reg underscore A, right? And here we can print the value of reg B. Now let's write hash 15. Actually we are giving some delay actually, and reg underscore A of 2 is equal to 1 tick B1. Dollar display time and reg A of 2. Now let's do some change the value of delay. Let's say it is 10 and I am writing like reg B, let's say 15 down to 13 is equal to x y z. Again dollar display reg B 15 down to 13. Now let's say I am writing count is equal to count plus 1 and want to print it. So now let's run this code and we'll try to understand the functionality of blocking assignments. So now we can see at here it is printing this line. So here time is 0 and count value is 0, right? Because we initialize count with 0. Now we want to print the value of reg A. So value of reg A is we put 0, so it is 0 at time 0, right? Again I am writing reg B is equal to reg A and want to print the value of reg B. So value of reg B is 0 at time 0. Now what we have done, we have given a delay of 15 nanoseconds. So reg A of 2 is equal to 1 tick B1. So at 15 nanosecond time it becomes 1, the second position of A, right? And after that hash 10 nanosecond reg B 15 down to 13 should be x, y, z. So what will be the value? X is 0 and this is 1, y is 1 and z is 1. So 1 and 2, that means 3. It will take means 0 1 1. So 3 in decimal, right? So 3. But it is not giving the time hash 10, it is giving 25. Why it is giving 25? Because hash 15 time is here and hash 15 plus hash 10, that is hash 25, right? That's why it is giving 25 time. 25 nanosecond as time. And after that I want to print the value of count is equal to count plus 1. So previously value of count was 0 and now plus 1, that is 1. So it will print the value of count 1 at which time? 25 time, because there is no delay between this statement and this statement, right? So this is the behavior of this code. And now come to the next point, that is 7.2.2. They are non-blocking assignments. So just I'm just performing the same operation on the same code, right? So the only difference is non-blocking will be right like this. This is the way how we can write non-blocking statements. This is the only difference. Now we will run this code and see the difference between blocking and non-blocking. So it is giving count value as x, reg value as x. It is giving default value. So to avoid that thing, we should provide #1 delay like this. Okay, first I will tell why it is giving like that. What is the reason actually? Okay, we have initialized count with 0, but it is printing x. And in all over the result, count is x, reg A is x, reg B is x, right? And reg B 15 down to 0, that is x, count is 0. So it is only taking the default value. It is not printing all these values. So what is the reason for that? So reason is, first of all, what the tool will do, it will take the right hand side of non-blocking assignment. So right hand side is 0, here 16 tick B0, reg A 1 tick B, XYZ, count plus 1. So what it will do, it will consider all this statement at a time and put their value in individual some internal registers, right? So it will store the value in some register 0, it will store this value in some register that is 0, it will store this value in some another register, it will store that 1 tick B1 in another register, like that. And when it comes to this statement, and means when this thing is finished, after that only it will update all these value to the LHS, left hand side. So to understand this, we can write like this, or we can give some delay so that the value should be updated like this. Let's say like this, and just control X, we can write like this, control V. Now we will try to run it again. Okay, there is some error. Okay. hash. Now you can see here it is giving first of all it is giving time is 26 at 26 26 26 26 all the way 26. What is the reason? Because what happens, it has taken all these right hand side of the statement and put in some temporary registers, and these two statements this statement have delay of 15 nanosecond, it has 10 nanoseconds, so total delay will be 25, and after that we are putting one delay over here, so that's why it is giving the same time 26 nanosecond. And the final value, what will be the here, the value of count, that is 1, so that's why it is printing 1 over here. It is not taking this value, it will print this value, right? And after that reg A, so reg A, here we have declared reg A like 0, but here you can see we have put reg A of 2 is 1, that's why it is giving 4, right? You can write manually 10101 and you can see. Okay, now reg B is equal to 15 down to 13 x y z, so reg B 15 down to 0, that is x y z, so 0 1 1, that is 3, so it is printing 3, right? And here again it is printing the value of count, that is 1, right? So this is the way how the your blocking and non-blocking assignments takes place during simulation, right? There is a very favorite interview question, swap the values between two variables using using blocking statement and using non-blocking statement. So the same concept will work there, right? You can try by yourself. So now let's see seventh point, what we have done till now, 7.2. So come to the 7.3, that are conditional statements. Used for making decision based on certain conditions, right? So now we will see what are the conditional statements. So let's take one example. Let's say module JK FF and module, here we can write like J, K, Q, CLK and reset, all the pins of the flow, and input is J, K, CLK and reset, output is Q. So always we remember, when you are going to use the conditional statement, so your output should be reg type, right? So just declare it as reg. Now always at the rate posage of clock begin end. Inside that just write a condition, if reset is equal to 0, begin end, the Q non-blocking 0. It is a good practice, always use when you are using some conditional statement, then you should use always non-blocking in nature, right? Or if you are inside a always block, so always use non-blocking. So what I am saying, what the code is saying, at the rate positive edge of clock means at every positive edge of clock, all these statements inside the always block should execute, right? So first of all, I am checking a condition. If reset is equal to 0, it will check. If my reset is 0, then it will put Q as 0, means my flow will become reset. Else, if this condition is not there, then what happens? Else, begin end. Again, if, now there may be 4 conditions. If j is equal to 0 and end, k is equal to 0. So in case of jk flow, if j and k both is equal to 0, then q should be q. That is our first condition, means no change, right? This is the one condition. Else, if this condition is not there, then what happens? So let's say j is equal to 0 and end, k double is equal to 1, begin end. So that is the reset condition. So my q should is equal to 0, reset. Next condition, else if j is equal to 1 and then k is equal to 0, begin end. So q should is equal to 1. That is called set condition. Now one condition is only remaining when j is equal to 1 and k is equal to 1. So there is no need to write that condition, you can directly write else, because only one condition is remaining. So else, what will be the output? Output will be q non-blocking not of q, right? So first of all, we write a always block, start from here and end from this line, right? After that, I am checking my first condition with reset. If reset is equal to 0, then q is equal to 0. What happens if reset is 1? Then it will come to the else part. So else part start from here up to here. So inside else part, there are 4 conditions. First condition is when j is 0 and k is 0. Be careful, we are not performing any AND kind of operation. AND means we are just checking the value of j and k, right? It means when both condition is true, means when j is equal to 0 as well as k is equal to 0, then q should equal to q. Similarly, when j is equal to 0 as well as k is equal to 1, that only q should is equal to 0. Similarly, when j is equal to 1 as well as k is equal to 0, then only q will equal to 1. And last condition is else. I am not writing another else if. There is no need to write that, because only one combination is remaining. We have covered 0 0 0 1 1 0 1 1 is remaining. So else means the last condition, whatever the remaining condition. So q will be toggled, right? So this is the one way. Next is something called multi-way branching, that is 7.4. In this condition, can write and and after that always at the rate posage of clock begin and inside that in multi-way branching there is another statement like this one is called conditional statement using if else ladder. Another we can use case statement. So we can write the case and bracket and can write like this curly braces. So we can write reset j and k, right? Actually we are concatenating the values, okay, and here we can write like 3 tick b 0 0 0. At this point q should is equal to 0. What is the mean of that? It means this 0 is related to reset, that means your reset is 0 and j and k is also 0. So when reset is 0, so output will not depend upon j and k, output will directly 0 if reset is 0, as in this case, right? Similarly q is equal to 0. Okay, now just copy paste one. So now let's cover all the scenarios. So 0 0 0 1 1 0 and 1 1. So up to here up to 1 1 means our reset is 0 in upper 4 conditions. So output should be 0. It will not see the values of j and k, right? Now again in another next condition, put reset always high 1 1, right, and give the condition 0 0 0 1 1 0 and 1 1. So when reset is high and this is 0 0, so what happens? We are not doing anything, that means no change. Q should is equal to q, right? For next condition 0 1, that means we are doing reset, so q should is equal to 0. For next condition 1 0, so 1 0 means we are performing set operation, q should is equal to high, that means 1, and when 1 1 is there, so it should toggle its value. So q should is equal to not of q, right? That is and multi-way. So this is the one way. This is using if else ladder, JK flip flop using if else ladder. This is JK flip flop using case statement, and this is one more way. Instead of writing like this, actually this is a combination of your case statement and if else ladder. So let's see that code. So what we will do, this thing, after that always at the rate posage of clock begin end. This is actually advanced approach. So we will see here. I can write if reset is equal to 0, q is equal to 0, right? This is my one thing. Now else begin end. Now inside begin end, what I will do, I will call case. I will use case. So case j and k, right? Now I can give simply values like 2 tick B 0 0. So at this time Q should is equal to Q, that means no change, right? Now that is for 0 1. So the 0 1 is reset condition, it is 0. This is set condition, so Q should be 1, and this is toggle condition 1 1, so it should be not of Q, like that, right? So you can compare this approach with this approach or this approach. So it will take less number of line and perform the same functionality, right? So that's why it is called advanced approach. Means as per our need, we can merge if else ladder with case. We can call case inside the if else, or we can also call if else inside the case. Here we call case inside the if else, right? Next one is, that was 7.4. So 7.5 called loops. Used to perform repeated operations. Now first topic is 7.5.1, that is while loop. Let's take a line. We'll execute until the while expression becomes false, right? So module top and module integer, let's say I have to write one code for factorial, okay? So let's take one variable, let's say n is equal to 5. I am writing one code for factorial. So and take one more integer, okay, result, right? After that initial, begin, end. Now I have to write a factorial code in Verilog using while loop. So first of all we need to write like while n is greater than 1. So it will run until the condition become false, begin, end. And I also use one variable to store the value. So let's say result is equal to n actually. Now I can write result is equal to result into n minus 1. After that end, and I can write dollar display. Result is equal to percentile d result. So now try to understand this code, what we have done, what we have written in this code. First of all, let's say I want to make a factorial of 5. So what is the factorial of 5? 5 into 4 into 3 into 2 into 1. That means 5 into 5 minus 1, and again 4 means 5 minus 2, like that, right? So first of all, I have take this value n in a variable, that is result. So now the value of result is also 5 because it is equal to n and n has 5 value, and I am writing n is greater than 1, so it will only run up to this condition, right? Here I am writing result is equal to result into n minus 1. That means my we have stored value 5 inside the result, so 5 into n minus 1, the value of n is 5, so 5 into 5 minus 1, that is 4, so that will be 20. So it will store 20 inside the result, right? And also I have to write one more thing, we have to decrease the value of n, so n minus is equal to 1, that means n is equal to n minus 1. So here n was 5, so 5 minus 1, that becomes 4, again it will come here and it will become 4 minus 1, that is 3, again 3 minus 1, that is 2, right? So in this way it will give the value, right? So let's check whether it is working or not. There is some error near end. So what is the error? Begin and is there, begin and is there, line number 9. Okay, we forget to write semicolon. So result is equal to 120 because 5 into 4 into 3 into 2 into 1, right? Or this is showing the final result when it comes out to the loop. Or also you can write this statement inside over here. So at every iteration it will show the result. You can see first it become 20 because 5 into 4, that is 20, then that is 20, then 5 into 4 into 3 means 20 into 3, that is 60, 60 into 2, that is 120, 120 into 1, that is 120, right? Now again let's come to the next loop. Next one is 7.5.2, right? This is for loop. Again you can see sometimes I have read like this percentile d, and sometimes I am using percentile 0d. So what is the difference? The difference is d, so it is the integer, right? So it will give some space over here because integer has some width, right? So if you don't want to see the space over here, so you can write like this percentile 0d. So the gap will be vanished. Now you can see there is no gap, right? So next one is for loop. So few points regarding that. Has three parts. Initial condition, terminating condition, increment or decrement. So now we will write the same code using for loop. Let's say module top and module teaser n is equal to, let's say 4, and teaser result initial, begin, end. Inside that result is equal to n, and I am writing like for integer I, because we have to declare the type of the I. So here I am taking I as an integer. So initial value is 1. After that I is less than or equal to, let's say it should be n minus 1, and I plus is equal to 1. That means I is equal to I plus 1. You can write any syntax. Begin and result is equal to result into n minus 1, right? And can write $display inside or outside whenever you want. So what we have done, we have declared just some variable n is equal to 4. That means we want to make the factorial of 4, and another integer as name is result. Inside initial block I am writing result is equal to n. So result will become 4 because the value of n is 4. Now I is integer type is equal to 1. So it will start from 1, and I is equal to n I is less than or is equal to n minus 1, right? So what will be the value of I? It will be decided, means the terminating condition will be decided by this statement, right? And initial condition is this, I is equal to 1, and final condition, increment or decrement, is this, right? So here it will increase the value of I 1 by 1, right? And here it should be actually I, not 1, right? Because first time the value of I is 1, so it result inside result is 4, so 4 into 3, that is 2. Again I value becomes 2 because I is equal to I plus 1. So again it will reduce that value and multiply with that result, right? So what should be the factorial? 5 into 3 into 2, that is 24. Sorry, 4 into 3 into 2, right? And similarly you can check for 5 also. That is 120, right? So now we have done the factorial code using while loop, using for loop. Next one is, let's say, repeat loop. So it will be 7.5.3. Repeat loop. So just write module top and module integer n is equal to 5, integer result integer m. I am taking one more variable, initial, begin, end. Inside that I am writing like result is equal to n, and m is equal to n, not like that, okay, right, repeat. So just write, yeah, m is equal to n and repeat, it will be n minus 1 time, I think, begin, end. Here I am writing let's say m minus is equal to 1, and result is equal to result into m, right? So what we have done now, first of all we take the value of n inside the result as well as inside m. Here I am writing n minus 1 time, means if it is 5 it will run only 4 times. So 5 into 4 into 3 into 2 into 1, right, like that. So here I am writing m minus is equal to 1, that means m is equal to m minus 1. I am decreasing the value of m because right now m is 5, here it will become 4 and the result is our 5. So 5 into 4, right? Again it will repeat their value. In next iteration it will again perform the same things, right? So let's check. You can see it is showing 125 into 4 into 3 into 2, right? Now next is 7.6.4. It is forever loop. So it will run forever until break condition occurs. Module top module and module, let's say integer n is equal to 5, integer result integer m, initial begin end, like result is equal to, let's say, n, and also write m is equal to n, forever begin end, inside that m minus is equal to 1, and I am writing result is equal to result into m, and here I am writing n minus is equal to 1, I mean just decreasing that value, right? And here I am writing one condition, if the break condition actually, n double is equal to 1, at that time break, right? Dollar display, okay, and directly copy paste that thing. There is some error near n, line number 11. I'll forget to put semicolon. Now you can see result is 120. So what we have done in this code, we have taken two variables, result and m, right? So first of all we initialize result with n as well as m, initialized with the value of n. Inside forever I am decreasing the m, and it will again multiply and multiply. Here I am decreasing the n to check my loop. When n becomes 1, then it will break this loop, and it will come out, the control will come out from the loop and execute this statement, right? So we have done with repeat loop, for loop, while loop, like that, forever loop. And the next one is sequential versus parallel blocks. That is 7.6.1. Okay, that is 7.5.4. right, and that is 7.6.1. So let's take one example, module top and module. Inside that, initial, begin, end, dollar display, can write statement 1 at the rate time is equal to percentile 0t dollar time. The same statement with some delay, let's say hash 5 nanosecond, hash 5 dollar display, the same statement. After that you can change the name, it is statement 2. Again with some delay, let's say hash 5 is there and this is statement 3. Again put some delay, let's say 15, and this is statement 4, right? So now just execute this block. So first statement will print at 0 time, next statement will print 0 plus 5 time. As you can see, for first statement, statement 1, that is 0 time. The next statement has a delay of 5 nanosecond, that means 0 plus 5, that is 5 nanosecond for statement 2. The next statements have some delay, 5 is there and 10 is there, so it will take 15 nanosecond. And next one has, so next statement, statement 4 has 15 delay over here and 5 plus 10, 15 over here, so it will print at 30 nanosecond, right? Now we will see the same statement inside for join, that is parallel in nature. So whatever we write inside the begin end, they will be part of the sequential execution, and if we write anything inside for join, they will be the part of our parallel execution. they also called threads. So Verilog supports only fork join, but System-Verilog have 3 types of threads: fork join, fork join none, fork join all, and fork join any. Right, but it is in Verilog, so we will do only the limited things, whatever Verilog supports. So what happens now? All the statement will execute in parallel, not sequential. So now you can see the first statement executed 0 because there is no delay. Next statement is executing at statement 2 is executed at 5 nanosecond, and next statement is executing at 10 nanosecond, statement 3, and final statement executed at 15 nanosecond. While in previous case it was on 15 and it was on 30, right? Because if you are performing the sequential operation, so delay will be add. But if you are performing some parallel threads like inside fork join, so they all are work parallelly. That's why the delay is not added, right? So this is called parallel block. Sequential block. Next one is, we'll see nested, means combination of parallel and sequential. So let's write module top and module initial. Let's write fork join. Inside that I am writing like dollar display, or I can directly copy paste from here. So statement 1, and after that let's say I am writing inside fork join, I am writing begin end. And here I am writing, let's say has okay, just and here let's say I am giving some delay, that is has 5. This is statement 2. Again I am giving some delay, that is hash 10, and there it is statement 3. Five, 6, and just write one more statement over here. Let's say it is at hash 15, and this is 1 2 3 4 5 6, that is 7. Statement 1. So that is executed at 0 time. But try to understand, we are writing all the statement inside a fork and join, right? So this is called one thread. This begin end will call another one thread. This begin end call another one thread, and this is one another thread. So 1, 2, 3 and 4. So they are 4 parallel threads actually, right? So first of all, it is printing this statement at 0 simulation time. Next one, it will comes inside this. So this is one thread. If I am seeing from outside, I am seeing from here, but inside begin end they will execute in the sequential order. So here it is printing statement 2 at time 5, right? After that, it will not come to here directly because it already consumed 5 nanosecond, right? So it will come to the here next statement, because this block and this block runs parallelly. This statement, this block and this statement all runs parallelly. So it will print statement 5 at 5 nanosecond. After that, it will come to the here. So here, because it is also working as an independent, so at 15 nanosecond it will print the 7th statement. After that, it will comes here, it will check the 10 nanosecond because it is already executed, right? So at 10 nanosecond it will print statement 3, and after that at 10, not 10 actually, 5 plus 10, that is 15 nanosecond it will print this statement, and similarly 15 nanosecond this will print this statement. Why this statement get priority? Because they are parallel threads, right? So in this way, parallel threads and nested threads are works, right? Okay. So next one is that is 7.6.1. So it will be 7.6.2. Named block. So block can be given name. Local variable can be declared for the named block. Named block can be disabled. Their execution can be disabled, their execution, right? So let's see one code. Module top and module. Integer a is equal to 5. Initial, begin, end. Block 1, right? So this is the named block. I am giving some name to that block, right? After that I am writing integer b is equal to 10. Okay, this is end. Now initial, begin, end, I am writing a is equal to a plus block1 dot b. I can write like this. After that, dollar display A is equal to percentile D A. Now we will check what happens. You can see the value of A is 15. Why it is 15? Because value of we have written A is equal to A plus block1 dot B. So inside block1 there is something B, right? So it will be accessed like that, and B is 10 and A is 5. So 10 plus 5 becomes 15, right? And let's say if I am writing simply like A is equal to A plus B, right? And just comment this line. I am not going to access the variable B using this block name. So let's see what happens. It will give error, undefined variable, because the definition of variable is inside this block, right? We cannot access like this. Okay. Now next point is 7.6.3. disabling a named block. How we can disable? So module to and module integer I is equal to 0, initial begin end. Inside that can give some block name, block underscore 1, and inside okay, let's say while I is less than 16, right? Begin end. Inside that I am writing $display printing the value of I is equal to percentile D, right? And after that, let's say I am writing if I is equal to 10, begin end. $display display disabling block, means I is reached to 10, and after that we can write disable, after that block name. So what is the block name? Block underscore 1, right? Here I can write I plus is equal to 1. That's it. So what we have done, we have declared an integer I is equal to 0, and after that initial begin, give a block name, that is block 1, and we are writing a loop to printing the value of I. So it will print up to 0 to 15, but at I is equal to 10, when I become 10, I want to break this loop, right? So I have written the condition disable block 1 inside if, and after that I am increasing the value of I. Just try this code with simulator. You can see disabling block I reached to 10, right? So 0, 1, 2, 3 up to 10 it will print. And let's say if I write like this, I is equal to 8, what happens? So it will work only 8. It is printing 10 because I have written over here 10, right? So this is how we can disable Now next one is, let's say, some coding example. So our first is 4-bit up counter. So how we can write? So module up count and module count reset clock, and inside that I am writing output reg 3 down to 0 count, input reset and clock, always at the rate postage of clock begin end. Inside that I can write like if reset is high, begin end, count should is equal to 0, else count should is equal to count plus 1, right? So what we have write? We have write like if reset is high, then count is 0, otherwise it will always increasing in nature, right? So let's write a test bench to verify that behavior. Module top and module, inside that reg reset clock, and wire is count, up count, that is DUT, count reset clock, and initial begin end I am writing like clock is equal to 0, forever #5 clock is equal to not of clock. Here I am generating clock using forever loop, right? Initial begin end, inside that let's say I am writing #3, I am writing reset is equal to 1, and after #7 means after 7 nanosecond RST should is equal to 0, right? After that I am writing again initial begin end, inside that give some delay #200 $finish, initial begin end. Inside that we have to write some logic to see the waveforms, like $dump file name will be dump.vcd $dump where's actually 21, right? So let's run this code. It is giving some error near line number 1. Okay, So guys, you can see, okay, get signal. It is giving count value single, but it should be in vector. So what is the problem? We didn't declare here the dimension, right? 3 down to 0. That was our mistake. You can see the value. Here is the reset, and in this region it is 0. When reset is there, the value is 0 as per our logic, right? Because what we have written, when reset is high, output should be 0, else count is equal to count plus 1, right? The same thing it follows, when reset is high, count is 0, else count is equal to count plus 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E, F means 0 to 15. After that again 0, 1, 2 like that, right? So it is working fine. So again, let's say I want to see one more example. So let's say next one is four-bit down counter, right? So only the difference is when the reset is there, just initialize the value to high. That means 4 tick B 1 1 1 1, else count is equal to count minus 1 because it is the down counter, right? Nothing else. So just run this code. Again the same problem is there, it should be 3 down to 0. So you can see when reset is high, the output is F, and after that it is decreasing, F to E, E to D, then C, then B, then A, then 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and again F, right? So it is working in decreasing manner, that means down counter, right? So it should be 3 down to 0 actually, and same here. So guys, this is all about the Verilog, what we discussed in this complete Verilog coding program. So there are lots of code in Verilog, like single port, double port, RAM, some counters, some swapping variables, some memory is there, some FSMs related kind of thing. So if you want to learn something and if you have some doubt, then you can make the comments. Also I am also providing the paid training program for VLSI students, means the students who are interested to make their career in VLSI on front-end verification. So complete program will have digital electronics, Verilog, System-Verilog, UBM plus AMBA protocols. At least 2 protocols we will cover. We will do UBC and BIP development using Verilog, using System-Verilog and UBM, right? So if you have any query, any kind of thing, just you can comment in the comment box, or you can ping me on my WhatsApp. My WhatsApp number is 99976150007, and if you are interested for the paid training program or any doubt, you can ping me on WhatsApp, and I will also share this number in the description box. Thank you so much.